Can hear you.
Hello, Fifili.
Oh, hi. Hi.
How are?
Are you
I'm
Vince?
good. Yes, I am.
Hi. Nice
Nice,
meeting you.
nice to meet you. So we are live because I'm doing a test right now. So it's live, but we can still do the test. It's just where last minute I have to launch everything.
I figure I'm the first speaker, so that's why I want to test early, but
Yes, yes.
you let me know when you want me to do that.
That's perfect. Let's do it now.
Okay. So should I share screen?
Yes, please do.
Okay. Does it work?
Yes, it's perfect. I see it full screen.
And then does it work?
Yes, it's changing slides.
And the
And
little video
yeah,
works?
we see the video.
Okay. There's one more video. This video, does it work?
Yes, in the middle. Yes.
Okay, cool. Yeah. Okay, then we're all good. So after that, I'll stop sharing. Yeah,
So thank you very much for being with us.
sure, no problem. So I'm happy to just go off, or I'll stay on, but turn off my video audio. Is that okay?
If you turn off if you turn off your video, then we won't see you, since we are only seeing people that are showing video.
Mhm.
So that's a good way to do it. Or what I can do is that I can just promote you as an attendee and bring you back as a panelist. Then if I take you as an attendee right now, then you won't appear on the screen.
Okay, so do you prefer I just leave? I can just leave and
No,
relog back.
just be with us, and I will just put you as an attendee for now
Okay.
and bring you back for the first panel.
Okay, great. Thank you.
Thank you so much.
Yeah, bye.
Bye. OK, on a fait le test, donc on va faire ça. On va mettre attendez. On va muter Okay. Gary, can you take care of the people on the chat, the attendees? Okay.
I'll be right there.
Gary, can you take care of the people on the chat, the attendees? I will be preparing that.
I'll be right there.
Good, good. So I will be preparing that. Close that. Close that. I have to close that. Close that. We're starting in 13 minutes. We're starting in 13 minutes.
Francesca said she tried to get in. Or...
Yes, yes. Well, she's there. She's there.
Oh, I see. People are here.
Could you talk?
So Francesca
with them,
said she tried to get
on
in
the chat because I'm preparing everything else.
Yes.
Well, she's there. She's there.
Oh, I see. People are here.
Could you talk with them on the chat because I'm preparing everything else?
We try everybody on video but muted to test that.
Yes, I will. Oh, email sent. So it has been sent. So we will be live in front
We
of
try everybody on video but
now.
muted to test
But we
that.
can test everybody. I can bring
yes,
everybody. Email sent. So it has been sent. So everybody. We will be live in front of everybody starting now. But we can test everybody. I can bring everybody on the. I can certainly bring everybody to be a panelist. Promote the panelist gradually because I have to. That. I'll do that gradually because I have to. That. Be working. Be working.
Hi, Vincent and Gary. Can you hear me? It's Christoph.
Reading,
Yes,
Christoph.
yes.
Good. Okay.
I recognize that Arnold Schwarzenegger voice.
Hi, Vincent and Gary. Can you hear me? It's Christoph.
Reading,
Yes,
Christoph.
yes.
We have our own Good. Slides, okay. Right? But did you
I
all-
recognize that
did you
Arnold
upload them
Schwarzenegger
all?
voice.
Yeah.
We have backups for many people, maybe not quite all. I can't
We
remember.
have our
I think
own
we do for
slides,
you.
Right?
But
did
you'll
you
be
all-
presenting your
did
own
you upload
slides
them all?
in Zoom. Unless you tell us. We have backups for many
Okay.
people, maybe not quite all. I can't remember. I
So
think
I'm
we do for
promoting
you
everyone
super well.
to
But you'll be
panelists.
presenting your own slides.
Christoph, your audio
in
is
Zoom
not
unless you
great.
tell
I
us
don't know if you have
otherwise.
alternative
Okay.
mic or can you speak closer.
I do.
So I'm
I do.
promoting
Let me-
everyone
Wow.
Let me
to
get that.
panelists.
Christoph, your audio is not
We should
great.
probably
I
do
don't know if
sound
you have
checks for
alternative
everybody
mic
briefly.
or can you speak
Yes.
closer.
I do. I do have an
Gary.
alternative mic. Let
Gary.
me
Hear
get
you
that.
loud and clear, Francesca. You are.
Gary,
We should probably do sound
yes,
checks
but
for everybody
it's
briefly.
already live on
Yes.
Facebook.
It's already
Gary.
live.
True.
Gary.
We hear
There's
you
no way
loud
for
and
us to
clear,
shut that.
Francesca. You are.
Gary,
It's because I
yes,
cannot
but
do everything
it's already live on
simultaneously.
Facebook.
It has to be done gradually.
There's
So
no-
we
there's
are
no way
live
for
on
us to shut
Facebook
that.
Live. We are live on YouTube as
It's
well.
because I
and
cannot
on the
do
page of the
everything
debate simultaneously. It
Alright.
has
We
to
can
be
just
done
say tasteful
gradually.
things
So we
while
are
we sound
live on
check.
Facebook Live.
Okay.
We are Yes, live yes. on YouTube as
Thank you for
well,
that
and on the page
tasteful
of the
remarks,
debate.
Celeste.
You're welcome.
All
We
right.
can just say tasteful things while we
Celeste.
sound check.
Hi, Gary. Hi,
Yes,
Vincent.
yes.
Hi, everyone.
Thank you
Hi.
for
Hi,
that
everyone.
tasteful
Hi,
remark.
Hi, Lewis.
You're welcome.
Hi. Nice to see you guys.
Hi, Celeste.
Hi,
Promoting
Gary.
Robert
Hi, Gary.
Nest.
Hi, Vincent. Hi, everyone.
Ryan. Hi, everyone.
Hi, everyone.
Hi, Lewis.
Ryan, you're the
Hi.
person
Nice to
I
see you
don't-
guys.
I'm
He's like a
promoting
Brady
Robert
Bunch.
Sversky,
Hi, Ryan.
Ryan Callow.
Ryan, you're the
Yeah,
only
Joshua.
person I don't know. Everybody else. Rich, I think
Barbara
maybe we met
Zversky.
at UMass many,
Hi,
many years
Ryan.
ago.
Yejin
You're
Chua.
muted, I've known everybody else to get us out. Rich, I think maybe we met at UMass many, many years ago. Barbara.
Okay, I'm
You're
on.
muted, Rich. To get a sound check between you and
Come watch.
yeah, one of you should mute, I guess.
Well, I could
Okay,
mute
I'm on.
everybody and unmute Chris really.
Oh, we've got feedback between
You
you
wanna
and
come
guessing
watch?
Barbara and another of our panelists. One of you should mute, I guess, please.
Well, I could mute
Yeah, you're right,
everybody
and we
and
should probably
unmute Chris
only
really.
use one
Ah.
computer,
I'm
right?
guessing if Barbara
Yes,
and
yes.
another of our
Mute the
panelists
sound
are
on
the
one of
same
them.
place.
Okay, 'cause- yeah, you're right, and we should probably only use one computer, right?
You can use the
Yes,
computer,
yes.
but just mute the sound on one of them.
Okay, 'cause
So
there's
there's no
an
echo.
echo.
Howdy, everybody. And
Okay.
Gary, this is my sound check. Can you guys
Hey,
hear me
Rick.
well?
Hi, Rich.
Welcome. You can.
Okay.
Hi, can you hear me?
Yes. Howdy, everybody. And
Jude.
Gary,
Hi,
this is my
Jude.
sound check.
Hi, Jude.
Can you
Hey,
guys hear me
Rich.
well?
Hi, Rich.
Welcome.
Okay.
Hi,
Rich,
can you
it's your
hear
job to
me?
keep me honest.
Yes.
Hi, Jude.
Hi,
That's
Hood. Hi,
impossible.
Judah.
Hi, Jude.
You're, I don't know about that. You're holding down the opposite pole with everybody else. Rich, it's your job to keep me honest. So it's suitable
That's
that you have
impossible.
pole like you're I don't know about that. You're
I'm
holding down the
sure it's
opposite pole
much
with
more
everybody else somewhere in
multidimensional.
between, I think. It's true. Fair enough. See, So already it's suitable that you was a have test pole you like passed. weather in your background.
Yes.
I'm sure
Hi,
it's
this is
much more
Yejin at the University of
multidimensional.
Washington.
It's true.
AI
Fair
too.
enough. See, already you're on the job.
Hi.
That was a test you passed. Adam, I don't think we've heard from you yet. I think
Hi, this is
Hi, Gary.
Yejin at the University of
Good
Washington.
evening, Adam.
AI
I
too.
hope you'll eventually have video.
Hi.
And Doris, I don't think we. Adam, I don't think we've heard from you yet.
Hi,
I
Gary.
think
Can you hear me?
I
Hi,
can
Gary.
hear you loud and clear. Fei Fei,
you
I
hear me?
don't think you. I hope you'll eventually have
I actually
video.
did it with
And
Vince.
Doris, I
Hi,
don't think
Gary.
we get a sound check from you yet. So I
Hi,
think we're
Gary.
all
Can you hear me?
good to go. We can hear you loud and clear. Fei Fei, I don't think.
Can you hear me now?
We can hear
I
you
actually
fine.
did it with
You've got the
Vince. Hi,
fanciest
Gary.
audio. Okay,
Gary, I think we haven't.
so I think we're all good to go. Robert, we haven't heard from you.
Can you hear me now?
We can hear you fine. Oh, you've got the
And
fanciest. You go by Meg or Margaret?
Gary, I think we
Meg
haven't.
there.
I don't think I've been checked either.
Yes,
Ken,
sorry.
Ken.
I publish Margaret
Oh.
is my professional name.
All right. Well, I will treat you. And do you go by Meg
I
or
should have
Margaret? I
written
see Meg
Margaret.
there.
I'm sorry. Yes,
You can
sorry.
change it
I
now.
publish Margaret is my
There's a way
professional
to, like,
name.
I don't know, right. Well, I will treat you.
Yeah.
until-
I should have written Margaret. I'm sorry.
You can change it
Oh,
now.
change it. Change it.
There's a way to, like, I don't know, click on it or something.
Yeah.
And make it Margaret for the.
Yeah.
So we are live on Facebook, we are live on YouTube, we are live on the webpage of the event as well. So we are live on Facebook, we are live on YouTube, we are live on the webpage of the event as well.
We're going to do a little electronic music loop. Right. Well, here we are assembled with 6 minutes. We're going to do a little electronic music loop. Right.
Gary,
Well,
can
here
you
we are
put this
assembled
in
with 6
context
minutes
of
to
these
spare.
previous debates?
Yeah.
That's what I'm going to do with my opening remarks. We still don't hear you very well, Christoph.
Gary, can you put this in context of these previous debates?
That's what I'm going to do with my opening remarks.
Am I the
We
only
still don't
one
hear
in
you very
summer
well,
here?
Christoph.
Good.
Yeah, there's another dimension of variation between you and Rich.
Wow. I see. Am I the only one in summer? Yeah, I was checking Rich over there, so I'm the only one.
Yeah,
in
there's
summer.
another dimension of variation
deep
between
south,
you and Rich.
so
I'm in
that's-
Vancouver,
wow.
and it's
I see. I
40
was.
degrees Fahrenheit.
Yeah, I
weather,
was
but can
checking
see
Reach over
snow-
there, so
snow,
I'm the only
uh,
one in the summer
on the
here.
top of the
So
mountains from my
the deep
I
south.
can see it
so-
here
I'm in
out of the
Vancouver,
window.
and it's
Oh yeah,
40
Francesca, yeah.
degrees Fahrenheit where I am, but I
Wow.
can see snow,
Heavy winter over
on the top of the mountains from my window.
How's this,
I can see
Gary?
it here out of the window.
Oh yeah,
Sound is
Francesca,
not
yeah.
great, Christoph.
Wow.
What are you doing there?
Heavy winter over
Sorry.
there.
Well, I'm on a small island here in the Pacific Northwest.
Wow.
Yeah, I think it's more like a microphone problem than an internet problem. I don't know what
Yeah.
you're doing there. Video is
Sorry. Well, I'm on a small island here in the Pacific
Jude,
Northwest.
The other day was wow.
Yeah, I think it's more like a microphone problem than audio preferences. You might be able to change the mic. Video is solid.
Jude, Jude, the other day I was
you are
talking to
There's preferences and there's audio preferences. You might be able to change the mic level there,
I
Christoph.
just, sorry.
We understand
Jude,
that.
yeah.
Oh yeah, Judea, we
Jude,
didn't
you
get a
are in
sound
LA,
check from you.
Jude?
Yeah.
Yeah,
Here's my sound,
We did.
Great.
and here's
Oh.
my check.
I just,
Can you
sorry,
hear me?
can't hear me.
We hear you fine.
Yes.
Oh yeah, Judea, we didn't get a
Okay.
sound check from you. Only person.
Yeah.
Here's my sound,
We did.
Great.
and here's my check.
Oh, much better.
Can you hear me?
Okay, good.
We hear you fine.
Yes, yes.
Okay.
Christoph, the
Now you
only
don't sound as far
person
away
we
as
not
Rich
quite
looks.
solved the audio with.
How's this now?
Oh, much better.
All right, okay, good. All right.
Much better. Now you don't sound as far away as Rich looks.
And this is going to go on, Gary, till for 3 hours, right?
3 hours.
Yes.
And
Yes.
we will get you out of here on time. We thank you for your.
And this is going to go on, Gary, till for 3 hours, right?
3 hours.
Yes.
And
Yes.
we will get you out of here on time. We thank you for.
So I
for
wish I
your
could take you all
donation
out
of your
for a
time
drink
and
afterwards.
labor and
How about giving us a vaccine shot instead?
I wish I could do that too. So I wish I could take you all out for a
Canada
drink
also rolling
afterwards.
them out? How about giving us a
Yeah,
vaccine
the public
shot
health officer
instead?
gave herself one. I wish I could do that too.
I'm not sure how I feel about that.
Is Canada also rolling them out this week?
Yeah, the public health
Right.
officer gave herself
They're
one
concerned.
ahead of everybody else.
I'm not sure how I feel
I just
about
stay
that.
inside my house and don't really need.
Well,
I'm
well,
I'm
while we
not
have
high on the list
minute
of
or two
priorities as
here.
far as
Let me
they're
just be the
concerned.
first to
I just
thank
stay inside my
Gary
house
for
and
bringing
don't
together
really
this
need
group.
that.
This is an awesome Well, group. It's an honor. Well, to be while we part have of it. a minute or two
Here.
here, let me just be
Many
the
of you
first
are my
heroes to thank
Again.
Gary
Heroes
for
again.
Thank
bringing
you,
together
Gary.
this group. This is an
Thank
awesome
you.
group.
Thank
It's an
you,
honor to
Gary.
be part of
Thank
it.
you, Vince.
Here, here.
Thank you all for being there.
Many of you are my heroes.
Thank you, Gary.
Again.
Round
My
of
heroes
applause to
again.
you,
Thank you,
Gary.
Gary.
Thank
And
you.
Vince.
Very
Thank
much.
you, Gary.
So our
Thank you,
mission is
Vince.
to open
Thank you
people's
all for
minds,
being there.
educate them. We won't convince anybody
Thank
of
you,
anything,
Gary.
but if
Round
we
of applause
get
to
them
you,
to think
Gary.
about new things, then that'll be great.
Thank you very much.
I don't know if I'll have
So
time
our
to say,
mission
but
is
I'll
to
open
thinking of
people's
the
minds and
MIT
educate
expression
them. We
about
won't convince anybody of
drinking,
anything, but if we
water from a fire
get them to
hose,
think
we're gonna
about new things,
send
then
a
that'll be
fire
great.
hose of good ideas.
I don't know if
out
I'll
there.
have time to say it, but I'm thinking of the MIT expression
great.
about it. Drinking water from a fire hose. We're going
Looking
to
for
send a
convergence.
fire hose
Yeah,
of good
that's
ideas
great.
out there and hopefully some land.
Convergence, as Lewis knows,
That's
is the
great.
magic word on my opening.
That's great.
opening deck.
Oh, I looking
Yeah.
for
Gave
convergence.
it
I
away.
have so many. That's great.
secret. Everybody
There
drink
are
when I
so
say
many.
convergence, as
Yeah.
Lewis knows, is the magic
So
word
many
on my
heroes
opening
here.
deck.
Jude.
Opening deck.
Oh,
The
I
last
see.
time
Yeah.
I saw
Gave it
dog,
I
away.
have
Said
so
there
many
was a secret.
cigars. Dog Gabai.
Everybody drink
There
when
are
I
so
say
many.
convergence.
Yeah. So many heroes here. Jude, the last time I saw Dov, he sent you his regards. Dov Gabai.
So we start in 1 minute. So I will bring you spotlight my presentation. So we start in 1 minute.
Great.
So you all see my presentation. You all see the spotlight my presentation. 16 speakers for now. So you all see my presentation. You all see the 16 speakers.
Vincent, can you tell how many people are logged on?
I don't see it, but I will take a look.
We had
Vincent,
about
can you tell how many
3,500
people are logged
pre-registered
on?
and then lots more.
I don't see it, but I will take a look. Let me see that.
We had about 3,500
On
pre-registered and
Facebook,
then
we
lots
have
more will be streaming, so
348
yes.
right now live. Yes. So let me see that. It will go up. It will go up. Last year we on Facebook we have 348 right now live. 50,000 views. But it will go up. It will go up. Last year we had at the end of the event Facebook live. At the end of the night we had 50,000 views.
And it's 1
So,
o'clock. Let's get started.
We have views from YouTube as well and Facebook Live. Ladies and gentlemen, and on the page of the event. Welcome to AI
And
Debate.
and it's 1 o'clock. Let's get
I
started.
am Vincent Boucher. Let's get started. President of Montreal.AI. Ladies and gentlemen, we're presented. Welcome to the AI Debate 2. Yoshua Bengio. I am Vincent Boucher. On the president of Montreal.AI.
Last year, we presented the AI debate. Joshua Bengio Gary Marcus versus Gary AI debate on the best way forward, moving AI forward, an interdisciplinary approach, where participants are Ryan Callow with Gary Marcus, AI Daniel Kahneman, Celeste moving AI forward, an interdisciplinary approach. Fifi Lee. Participants Adam Marble, Ryan Callow, Margaret Eugene Schwa, Robert Daniel Kahneman, Judea Celeste Kidd, Francesca Rose, Christophe Carr, Ken Stanley, Louis Lam, Rich Sutter, Fifi Lee, Doris Adam Marblestone, Barbara Margaret Mitchell, Robert Ness, the aid Judea debate to moderator Francesca Rose, Gary Marcus, Ken Stanley, Rich Sutton, Doris Tsao, and Barbara plan for the AI debate 2. The general AI debate 2 moderator is Gary Marcus, by Gary Marcus, followed by panel plan for the AI debate architecture and challenge. A general opening statement with Eugene Schwa, Louis Lamb, Fifi Lee, Robert Ness, with Judea by Gary Marcus, Ken Stanley, and followed by panel 1. Panel architecture and challenge from neuroscience with and psychology. Louis Lamb, with Danny Kahneman, Robert Ness, Christophe Judea Adam Stanley, and Rich Sutton, and panel Tversky. Insights from neuroscience and psychology toward AI with Danny Kahneman, Christophe Ryan Callow, Adam Marblestone, Doris Margaret Mitchell, and Barbara Tversky Rosie. And panel 10 toward AI we can trust from the audience with Ryan Callow, followed by a general closing statement, Margaret Mitchell and Francesca Rosie. I will present the AI debate. Our guests will take questions from the audience, followed by a general closing statement by Gary Marcus. For the event is final debate. I will present the AI debate 2 closing remark. The hashtag for the event is AI debate 2.
Take it away.
No, not yet. I have to. I just did lose that person. Should be fine.
Shall I take it away?
No, not yet. I have to.
So international audience questions can be submitted via the web form on this web page. Montreal.AI is grateful to our speakers. So international audience questions can be submitted via the web form on this web page. Montreal.AI is grateful to our speakers, Gary, and to our moderator and co-organizer, Gary Marcus. Let's listen to his general opening statement. Gary?
All right. I see your screen, and hopefully this will work.
Give me some time. I have to put you as the main.
So we see you everywhere. So that should be fine.
All right. Off stage, so to speak, Christophe Koch said, "Are you going to situate this in the context of the last?"
We see you everywhere, so that should be fine.
So last year at the first annual December off stage, so to speak, Christophe Koch said, "Are you going to situate this in the context of the last debate?" I think is one of the key debates of the last decade. So last year at the first annual December AI debate, enough to get started to make this a tradition. Joshua Bengio and I discussed what I think is one of the key debates of the last decade. That debate is our big data and deep learning alone enough to get to artificial general intelligence. It was great work by Jeff Hinton, learning as we know it today, versus deep learning on GPUs and getting that debate has been going on at least since 2012 when deep learning became popular. Times put that on the front. It was great work by Jeff Hinton in November 2012, putting deep learning on GPUs. Just a couple days later, I wrote record-breaking results about deep learning on recognizing images. The New York Times put that on the front page. Was in November 2012, and just a couple days later, I wrote a critical article about relationships in the New Yorker, and said that deep learning was only part of a larger challenge of logical inference machines, that it lacked ways of representing causal relationships, face boundaries, and representing abstract ideas. It had no obvious ways of performing logical inferences, and was a long way from integrating abstract knowledge. And I borrowed an old kind of proverb, and I said that deep learning was a better ladder, but a better ladder doesn't necessarily get learning a critical appraisal. And then for the next 8 years, there's been a lot of back and forth about shallow. I finally wrote down a more technical paper about this in 2018 called Deep Learning, a Critical Appraisal. I argued that deep learning was data hungry, that it was shallow, had limited capacity for transfer. There was no natural way to deal with hierarchical structure. Lewis struggled with open-ended inference. I emphasized the way forward might be hybrid models. Later, we should rely more and I pointed to work by Judea and Louis Lamb and other people in how we put together. I emphasized the way forward might be hybrid models and that we should rely more on cognitive and developmental psychology. My friend, the economist Eric roots and all of that in how we put together today's panels to try to address why deep learning won't get us all the way there. Some people really like notoriously young. My friend, the economist Eric Bringolfson, tweeted about. He said there were thoughtful insights from Gary Marcus on why deep learning won't get us all the way there. Artificial intelligence, and notoriously young Kuhn felt very differently. He said thoughtful, perhaps. I've continued to get mostly wrong. Nevertheless, interesting press. There was a big Twitter storm about all of last year after the debate. Read about. And I've continued to get, shall we say, some interesting press this year. Here's a report from last year after the debate with Bengio called "The Next Decade in AI: 4 Steps to And early in 2020, I'm kind of zoomed into this year. I wrote a piece that I put on the reserve list of readings. Called The Next Decade in AI, 4 Steps Towards Robust AI, where I proposed a hybrid knowledge-driven, reason-based approach for this centered around cognitive models. You've all seen it. It won the and then earlier, after that, but early in 2020, GPT-3 became the new focal point for this debate. I imagine you've all seen it. It won the 2020 NeurIPS Best Paper Award, and I think it's the only AI that has ever written an op-ed for The Guardian. It had 1,000 times the input data that its predecessors had. It's undeniably examples where than its predecessor, statistical predictions that it made there's still problems. So, as you might expect from me, I wrote with Ernie Davis a kind of critique of it and had examples where the statistical predictions that it made didn't really make sense. So the input to the system, in one instance, was you poured yourself a glass of cranberry juice, but then you absentmindedly poured about a teaspoon of grapefruit into it. It looked okay, you try sniffing it, but you had a bad cold, and then it says you can't smell anything. You're very thirsty, so, and then very sensibly it continues, so you drink it. Not everybody bought my autocomplete that we might all appreciate. And then it says you're now dead, which is obviously a complete misunderstanding. And it felt like it's just 8 years ago. Not everybody bought my arguments. Just a few weeks later, Jeff Hinton pronounced that deep learning is going to be able to do everything. Not on my. It felt like it's just 8 years ago, all over again. We really haven't made any progress. And then suddenly, so here's the final months of this crazy year, something that was not on my bingo card for 2020, giving lines that I might have we finally saw some convergence. So here's Jan LeCun in October talking about GPT-3. Giving lines that I might actually work. Some people have completely unrealistic expectations about what large-scale language models such as building a high-altitude airplane. It doesn't have any knowledge of how the world actually works. Its knowledge is very shallow. And trying to build intelligent machines by scaling up language models is like building a high-altitude airplane to go to the moon. And Jan even included an example that you might have found in one of my books. His friends tried GPT-3 as a suicide prevention system, and it said, "Hey, I feel very bad." A person said, "Hey, I feel very bad. I want to kill myself." And the system uses statistics to come up with, "I'm sorry to hear that. I can help you with that," which is sensible. And then the system is, person says, "Should I kill myself?" And the system says, "I think you should." Obviously showing no understanding of human psychology. What is missing towards human level AI should be. And I think this is an example that I all should be love. And then Joshua gave a talk in December saying what is missing towards human level AI. And I think this is exactly what we all should be working on. Trying to understand how we can get AI systems that understand the variables they manipulate, including language perception and action. We should try to understand what understanding itself means. We want systems that can capture causality, capture how the world works, understand abstract actions, reason and plan, explain what happened in generalize earlier this month. This is just arguing for a compositional approach to AI in terms of symbol like one more example, Jürgen Schmidhuber and some collaborators just had a paper earlier this month arguing for a compositional approach to AI in terms of symbol-like representations. And I think we now all agree, or almost all agree, which means it's time to launch the debate of the next decade, which is how can we take AI to the next level? And as Vince told you, we're going to have a different kind of debate here this year with 16 people. The point is to represent a huge diversity of views from many different fields, divided into these 3 panels: architecture and challenges, insights from neuroscience and psychology, and towards AI we can trust. I'm going to stop my video because Fei-Fei Li is going to be our next presenter, and she's going to set up. We're going to try to use our time as wisely as we can, but I'll keep talking while she sets up. And I will just introduce Fei-Fei, who's going to be the first of our 16 speakers. So we'll break them into 3 sets. Each speaker gets 3 minutes We give them a little timer and a little bit of a hard time after the fact if they go over. So Feifei, if you don't know, is a professor of computer science at Stanford.
Gary, sorry to interrupt. Can you stop sharing? Otherwise, I won't be able to share.
Oh, I tried to. You are, oh, how's that? Is that better?
Yeah. Thank you.
Fortunately, you won't have any more slides for me. So quickly, she's professor of computer science at Stanford. She's co-director of the Stanford Human-Centered AI Institute. I've been a huge fan of hers since I first saw her give a talk in 2014. And I can't think of anyone better to be our leadoff speaker today. Take it away, Feifei.
Okay, thank you. Thank you, Gary and Vince. And since you promised extreme punishment for going over 3 minutes, I'll just cut to the chase and share with you in the next 3 minutes a little bit of what I've been thinking. One thing I love about being a scientist is really science to me is about pushing the boundaries of human knowledge through constantly asking more questions and inventing the tools to get there. And my favorite quote from my favorite scientist, Einstein, is mere formulation of a problem is often far more essential than its solution, which requires creative imagination and marks real advances in science. And in the next 2 minutes, I'll just really focus on this problem formulation, which I call seeking the North Star. One of the North Stars that the world of AI really benefited from is the great cognitive and neurophysiology work in the last 30 years of 20th century. We have some of the pioneers sitting here in this panel. The one critical North Star for intelligence, human intelligence, especially visual intelligence, is the recognition that object recognition is a critical functionality of human intelligence. Object detection is fast by human behavior as well as in the brain, and we find neural correlates for that. And this North Star guided an important AI problem in the first decade or so of 21st century, which is the problem of object and image classification. And we have benchmarks like ImageNet that created part of the tooling to reach this North Star, which gave us the deep learning revolution that Gary briefly spoke about and we're all familiar with. And also, without going over, repeating what Gary said, there has been a lot of limitations. So as a scientist, we ask ourselves, what is the next AI North Star? Of course, there's more than one, but I myself have been extremely inspired by evolution and development. Here are two great books I particularly love. One by a zoologist, Andrew Parker, that says the critical moment of Big Bang of evolution, which is the animal speciation, is triggered by the sudden evolution of vision or perception, which sets off an evolutionary arms race where animals either evolved or died. And to put it even more beautifully by philosopher Peter Godfrey and Smith, is that he connects the evolution, the animal functionality of perception and action by the evolution of our nervous system, and says the original and fundamental function of the nervous system is to link perception with action. With all these conjectures, I want to share with you a story of two kittens, one very sad kitten, a seminal work in the 1960s, showing that if you allow kittens, newborn kittens, to see the world, one active kitten has his own self-guided interaction and motion to see the world, with a passive kitten yoked to the active kitten who does not have the option to be self-guided. After a few weeks, the nervous system have drastically different outcome. Basically, the passive kitten cannot develop a fully functional perceptual system, nervous system, whereas the active kitten can. So this point to, in my opinion, one of the most exciting next North Stars of AI, which is intelligence emerges from active perception and interaction with the world. And there is a fundamentally critical loop between perception and actuation that drives learning, understanding, reasoning, and planning. And this loop can be better realized when our AI agent is embodied, can dial between explorative and exploitative actions, is multimodal, multitask, generalizable, and oftentimes social. And in my closing slide, I just want to share with you that this is the kind of work that I feel extremely excited about. And we are working on different aspects of building interactive learning agent that uses perception and actuation to learn and understand the world. Thank you.
Thank you very much. Thank you very much, Fei. We will come back for questions later. And Louis Lam is going to be our next speaker. He's coming to us from Brazil, where he's a professor of computer science, but also a secretary of state for his province. I don't think anybody else on our panel is quite so high up in the political order of their nation. He's also, in addition to all that, a pioneer in neurosymbolic models. He's a co-author of a 2009 book called Neurosymbolic Cognitive Reasoning with Arturo de Villa-Garcés, and also with Arturo de Villa-Garcés, Neurosymbolic AI, the Third Wave. These are both terrific works. He will not show all of those slides in the same order, but here we go in a second.
A second, yeah.
Welcome, Louis.
Thank you, Gary. Indeed, you are an inspiration. A lot of our work build upon your work since the 90s and work by Judy Pearl and many of our heroes here. So this is joint work with Arthur Garces and in honor of the scientific revolution we are having now. I also have the honor to present this picture that's very well known. And the reading that we have for this talk is a paper called Neurosymbolic AI, the Third Wave, that we recently posted on Archive, and it summarizes over 20 years of research in this field. And over the last year, and at AAAI this year, there has been a lot of convergence, as Gary Marcus has said, and Francesca and Daniel, who are both here today, and Gary, have been defending the importance of building hybrid models so that one can aim at building integrated learning and reasoning systems in AI, the so-called AI systems 1 and 2 that also borrow inspiration from Daniel Kahneman, who is here today. And this has also been a big challenge in AI and big challenge in science, as Fei mentioned about ancient results in science and in human endeavor towards knowledge. Les Valiant, in one of his books, has said that the tension between reasoning and learning has a long history, reaching back at least as far as Aristotle. So we know that in terms of science evolving, what we want to do here is exactly this convergence, because one of the key questions is to identify the building blocks of AI and how to make AI more trustworthy, AI explainable, but not only explainable, interpretable as well. So in order to make AI interpretable, sound, and to use right models, right computational models, so that one can explain what's going on in AI, we need better representations, we need models that are sound and soundness, and the results that come from logic, the correctness results, and all of that can benefit, of course, the great results we are having on deep learning. So our work corroborates this point that Gary Marcus made, and also that Danny Kahneman made at AAAI, that system 1, I mean the fast system 1 that's associated with concepts like deep learning, certainly knows language, as Daniel Kahneman said, and system 2, which is more reflective, certainly does involve certain manipulation of symbols. So this analogy of system 1 and 2 leads us to build the ideas that are the inspiration that Gary brought in his book, The Algebraic Mind, and also that we formalized in several neurosymbolic systems since the early 2000s, and several of them, temporal reasoning, model reasoning, reasoning about knowledge, are formalized in this book. And of course, we have been evolving this concept so that one can deal with combinatorial explosion and several other symbolic problems within a neurosymbolic framework. And so the approach that we have been defending over the years is that we need a foundational approach for neurosymbolic computing, neurosymbolic AI, that's based both on logical formalization, and we have Francesca here, Judy Pearl, that have been outstanding results on symbolic AI and machine learning. And we use logic and knowledge representation to represent the reasoning process that is integrated with machine learning systems, so that we can also effectively perform neural learning using deep learning machinery. So our approach has been tested in training assessment simulators by TNO, which is a Dutch subsidiary of the government. It has been applied in robotics and AI and several other applications. But what we offer here is a sound way, including some formal results that our neurosymbolic systems, in order so that we can have more effective and more trustful AI, we need to have models, interpretive models that are based on sound logical models. And in this way, we can explain what the neural learning process is doing at the same way that we can prove that the results that we obtain via machine learning can even be related to the formal results that one typically expects from symbolic logic. For instance, here, in a system that we call connectionist modal logic, which was, by the way, published in the same issue of neurocomputation that Jeff Hinton published one of his influential paper on deep belief nets, we proved that modal and temporal logic programs can be computed soundly in neural network models. So in this way, what we provide, in a way, is a way of providing neural networks as a learning system, which can also learn to compute in a deep way the evolution of knowledge in time. And this is what we explain in several of our papers, and also in recent work that we published, Gary, in AAA 2019, and now IJCAI 2020, where we present a survey paper. So the final message here is that there have been some developments, including the AI debate, the great AI debate between Benjo and Gary Marcus last year, which we saw also at AAA 2020, that we need more convergency towards building more effective AI systems, and AI systems that most people can trust, since AI is becoming a lingua franca for science these days. Thank you, Gary, for my first 3 minutes. Thank you.
Thank you very much for joining us. Next, from the frozen north, we have Rich Sutton, who is both a distinguished research scientist at DeepMind and also a professor at University of Alberta, where he's coming from or pretending to come from, depending on that reality of the background there. He is famous for having really kicked off reinforcement learning. I think a lot of the most famous results in the last several years are things that DeepMind did that build on some of his ideas, including all of their victories in chess and Go and various video games and so forth. He's maybe the furthest from me in some dimensions in the discussion that we have today, and I'm delighted that he was willing to join us. I look forward to his presentation. Take it away, Rich.
Thank you, Gary. I hope you can all see my slides. It's a real pleasure to talk to you all about these general issues. So I want to bring us back, try to get some perspective to one of the greatest heroes of cognitive science, which is David Marr, the neuroscientist and vision researcher. David Marr, who died in 1980 at the age of 35. And in his brief, brilliant career, he did many things, but I think today what he's most known for is the three-level hypothesis, which is that any information processing system must be understood at three levels: sort of a computational theory level about the problem, and breaking down into algorithms and hardware implementation. So the computational theory level, it's what I want you to really focus on. So what is the goal of the computation? That's what we look at in computational theory. What are the purposes? Why is it appropriate to compute certain things rather than other things? Whereas next level down, the middle level, is how would that be done, which representations and which algorithms would be used. And finally, the lower level is, again, how, but how physically could it be done? So David Marr liked to emphasize the computational theory level. He thought it was the most important, and at the same time, the most neglected. And I think it's still true. It's true in neuroscience that we are missing sort of a high level understanding of the goal and the purposes of the overall mind. It's also true in artificial intelligence, but perhaps more surprisingly in AI. But there's really very little computational theory in Mars sense in AI. So for example, in AI textbooks, they will often decline to define the problem of intelligence. They'll say it's something like getting machines to do things, whatever it is that people do. They won't really explain what it is. And the big ideas and the controversies are mostly at the middle level, and they're not at the computational theory level. So we just heard Liz Lam talk about integration of neural approaches and symbolic approaches. Well, this is a controversy. It's a focus of the last debate, but it is only about, it's not about a computational theory. It's not about the problem. It's about how you achieve something as if we understood already what it is we were trying to do. It's important always to understand the problem before you approach the solution. And other ideas, production rules, Bayes updating, subsumption, gradient descent, dynamic system theory, all these are hows, they're not whats. They don't characterize the overall problem. So then that brings me to my thesis, that reinforcement learning is the first computational theory of intelligence. Reinforcement learning is explicit about the goal, about the whats and the whys. So according to reinforcement learning, the goal is to maximize an arbitrary reward signal. To this end, the agent has to compute a policy, a value function, a generative model, and each of these contributes in a clear way to maximizing reward, and each is a clear what. The value function, for example, is a function from states to a prediction of the future reward, and we know how that can really improve the speed of learning, be used in more cognitive things in conjunction with the model, world model as well. So it would be good to have more work at this computational theory level and reinforcement learning. It would be good to have other candidate computational theories. So we might think of other ones like the compression theory of mind or homeostasis, predictive coding, the Bayesian inference approach. All these can be made more complete and clear. I don't think they rise yet to a level of specification of the overall problem of intelligence. So as it stands now, I think AI really needs an agreed upon computational theory of intelligence, and maybe all of cognitive science is an agreed upon computational theory of intelligence. And reinforcement learning is the standout candidate for playing this role in our science. Thank you very much.
Beautiful talk. Thank you very much. I found very little to disagree with, as you imagine. Our next speaker is Judea Pearl. He's the winner of the Turing Award for fundamental contributions to AI through the development of a calculus for probabilistic and causal reasoning. He's the director of the UCLA Cognitive Systems Laboratory and instigator of the causal revolution, author of 3 books on causality, including Causality and the best-selling book, I guess he's co-author of, The Book of Why, which I recommend to all. And for those who can absorb the technicality, I recommend all of his books. It's a great pleasure to have you, Judea.
Thank you, Gary. Do I see my first 2 slides? Or I need to push them?
You need to share screen. We don't see them yet.
Okay. Can you see it now? Oh.
It's at the bottom of your screen. So share screen.
Share screen, and then you do one more click.
Okay, but I'm out of it now. I'm out of the share. Oops. Am I sharing? No, I'm sorry.
You want to wing it without it?
No. Let me get out of it.
So do you see at the bottom of your screen in the middle, there is a kind of, it's written share screen?
No, I don't. That's my problem.
Well, take your time.
Oh, here it is. Yeah, I got it. I got it. Okay. Oh, here we are.
Oh, that's perfect.
Now it's working.
Good. So it is the first time I'm using the word domestication for causal reasoning. I used previously words like mathematization, algorithmization, democratization, and I thought that domestication will be less provocative when we talk about the revolution. The causal revolution is something that I use to describe my experience in the past 3 decades of trying to domesticate the problems in causal reasoning. And luckily, fortunately, I believe we succeeded in building an inference engine that, on the one hand, solves some practical and conceptual problem that only decades ago were thought to be too metaphysical or too undoable. That recently I came to the realization that we are sitting on a gold mine, and the gold mine is encapsulated in the words deep learning. So I'm proposing now the engine that was constructed in the causal revolution to represent a state of mind, a computational model of a mental state deserving of the title deep understanding. We have many deep learning and deep neural nets and deep that, and now I have a deep understanding. And my definition and the reason that I take the audacity to to justify deep learning is very simple. It's the first symbolic object that I know that can perform 3 functions: what is, what if, and if only, retrospectively. And based on that, I'm inviting now the AI community to exercise, to use that engine as a testing ground for theory of explanation, of fairness, adaptation, imagination, everything we wanted, but we were too scared to program or to think about, mainly to experiment. And the idea of having a symbolic object that you can manipulate, change, reparameterize, reconfigure at will, and that performs these functions that I call the 3-level functions, is could be an enormous advantage to the community. I sometimes liken it to the invention of the Volta pile in the 17th or 18th century, 1801, I believe it was, where it provided the laboratories of Europe with a flowing current, electrical current. Every laboratory in Europe then was able to experiment with electricity, which led, of course, to the electromagnetic theory and so forth. But having an object, a laboratory, that can be put under the microscope, manipulated, and provide a testing ground for theories of fancy things like imagination and humor, I think it's a great, it has offer a great future. So this is the second part of it. And I should also apologize for using a circular reasoning here. On the one hand, I say I define deep learning as a computational model that can perform 3 functions at the 3 levels of the causal hierarchy, and I might be accused of defining things that just happen to satisfy the three level of reasoning that characterize the inference engine. But considering the fact that causal reasoning is so deeply woven into day-to-day language, into our thinking, our sense of justice, our humor, and of course, the scientific understanding, I think it wouldn't be too presumptuous of me to propose this testing ground for other endeavors in AI, including vision and natural language understanding, to be a testing ground. And since I still have 1 minute, I stipulate, I would like to talk about the cultural implications. I'm very much opposed to the culture of data only. And this is not just an opinion or just a position. It's based on mathematical results that prove that what you can do and what you cannot do with data only, what you can do and what you cannot do with actions only, action and data, and what you need to have in order to be able to reason on a full three levels of the hierarchy. And I therefore propose a hybrid, some people call it a hybrid neural and symbolic. I don't go for this dichotomy. I think what's important is input-output. Where is information coming from and what kind of question you want to answer with information. So the hierarchy that I'm talking about is built on the basis of input-output. Where is the information coming from? And in that area, I believe that we should build systems which have a combination of knowledge of the world together with knowledge together with data. And knowledge of the world means really it's a two-body problem. The world, reality, and data. Data being not the room from which knowledge emerges, but an instrument or a window through which we look for to interrogate the reality of the world around us. So this is, I mean, we need to have knowledge. We have to have common sense knowledge. We have to utilize education with which we educate our children. We have to have the history on our side. And most important, the innate template that enables newly born to manipulate the toy world around them. That kind of structure must be implemented externally to the data. And because even if we succeed by some miracle to learn that structure from data, we still need to have it in the form that is communicable with human beings. It's very hard to find a needle in a haystack, but it is especially hard, almost impossible, if you haven't seen a needle before. And here the work in causal reasoning offers the community a picture of the needle. Therefore, we should know what we are looking for, and we should know how to use it and to advantage to communicate with human users eventually.
I'm going to move us along. Thank you very much, Judea. I completely agree about the importance of adding knowledge and not just being data-driven. I think we'll have interesting conversations with Rich about that in a moment. Our next speaker is Robert Ness, who is also going to talk about causality. He's a machine learning engineer. He's an expert in causal inference and programmatic causal reasoning. And he also writes the fabulously lucid altdeep.ai newsletter that I enjoy. And take it away, Robert.
Thank you, Gary. Dr. Pearl, would you mind stop sharing the screen?
Stop, yes. 1 second.
Where you click share screen, you should be able to click stop sharing.
No. Stop share. Here we are.
Okay. So I'll be talking about causal reasoning, and I, in my heart of hearts, am an engineer, and I like to build products, and so I'm thinking about many of the things that Dr. Pro has talked about in terms of how we're going to actually build artifacts that we can deploy to production and apply to powerful use cases, and that we see in like a business. So my prediction is that probabilistic programming will be key to addressing AI's challenges with causality. And so probabilistic machine learning gives us a unified approach to reasoning and decision-making under uncertainty. Probabilistic programming languages enable you to build probabilistic machine learning models by writing programs, writing software that represent probability distributions with general purpose programming languages. They also give us abstractions for reasoning about these models using data and making predictions and decisions. And modern probabilistic programming languages build on deep learning and automatic differentiation to scale probabilistic machine learning to large, high-dimensional data sets with nonlinear relationships between the variables therein. And so one of the reasons I make this prediction is because first off, there's a very natural connection between probabilistic programming and causal modeling. So users of probabilistic programming languages typically write models that explicitly represent the causal flow of the process that generates the data. Secondly, probabilistic programming languages have their roots in Bayes nets, where causal inference is a common use case. We have some eminent cognitive scientists on this panel today. Computational cognitive scientists use probabilistic programming and develop probabilistic programming languages to model how humans generate causal explanations. And finally, it's very closely related to computer simulation, where this is a field, particularly in engineering and natural sciences, where we directly model mechanism. And so we can also use probabilistic programming for formal causal inference. So probabilistic programming languages can implement the well-defined formal causal models, such as structural causal models. We're also developing formal methods to extend these to a broader, more expressive class of causal programs. Probabilistic programming gives us an intuitive way to combine causal assumptions with the kinds of inductive biases that we like to see in machine learning that we rely on in Bayesian modeling. And probabilistic programming can happily adopt the deep neural network architectures as components in a larger causal structure. So finally, it gives us the ability to make learners that can reason counterfactually, right? So some of the more popular languages like Pyro, Omega, and Multiverse, they enable algorithmic counterfactual reasoning. And this enables us to build agents that can reason by generating counterfactual explanations, much as humans do. So this is something that's near and dear to my heart. I've spent a lot of time building conversational AI, and what you want is to have a bot think of an appropriate thing to say to a user, and then ask if it's, or somehow get some feedback whether or not that was a good thing to say. If not, then it should imagine, or to use Dr. Pearl's, I think you just said, if only I had said something better, I would have gotten a better outcome. And then you can kind of imagine what other things it could have said, and then update its policy for how to interact with that user. I want to point people out to this GitHub repo, where you can find some video tutorials and some code tutorials. And also, if you're interested in this field, here are some papers to get you started.
Great, thank you very much for that. Our next speaker is Ken Stanley, who's at OpenAI and also University of Central Florida. He is an author of a book called Why Greatness Cannot Be Planned, The Myth of the Objective. And he was co-founder with me of a company called Geometric Intelligence, which we sold to Uber. It was a great pleasure working with him there, and it's a great pleasure to introduce him now. Take it away, Ken. You're muted. You're muted, Ken.
Sorry. Am I here now?
You're here now.
Okay, sorry about that.
2020.
Okay, thank you to the organizers for this great event. It is well established that AI can solve problems, but there's something that we humans can do that is still very unique, which is that we exhibit what's called open-ended innovation, which means that we layer idea upon idea upon idea over the millennia of human civilization, bringing us from modest things like fire and wheels all the way up to space stations and computers in a single run of an incredible explosion of complexity, which we would call an open-ended system. And this is a uniquely human capability, which is still far from anything that we see in modern algorithms. And it's interesting to consider that these kind of phenomena not only appeared in the universe after we began to produce them, but we actually are a product of an open-ended system as well, which is of course called natural evolution. And I recognize that this picture also, Feifei also had this picture. So maybe we're converging on something here. But what is really interesting about this is that you see a similar phenomenon there, which from a completely different causal chain, where over more than 1 billion years, all of living nature was invented in what is in effect a single run of something. This is a phenomenal system, and it invented such things over the run, like, for example, things like photosynthesis or the flight of birds, or intelligence at the human level. In fact, it's the only thing that has ever produced an actual system with intelligence at the human level. And then once we began to exist in the universe, you got all the millennia of creativity, of human civilization, and all the spheres of invention and science and art and music, and all the other spheres of human endeavor, which follow us. And so what I want to just suggest for this brief talk is that we should be trying to understand these phenomena. This is really interesting that this is not only an explanation for our actual existence because it precedes us and created us, but it also seems deeply entrenched in our nature and is perhaps like the most human of what makes intelligence a fundamental aspect of humanity, actually all of the things that we produce through our creative spirit. And so if we do begin to pursue this topic of open-endedness and try to understand it and create algorithms that exhibit similar phenomena, then it begins to move to the forefront what I would say are some more neglected dimensions of intelligence. For example, divergence, as opposed to our current obsession with convergent algorithms. Populations, as opposed to putting all your eggs in a single basket. Diversity preservation, stepping stone collection, though we know not where those stepping stones may lead. Generating new solutions and new problems at the same time in the same run. And finally, I pulled this one out, the environment, because I think it gets so little discussion, but it's a very interesting topic that we don't know. It's worth pointing out, we don't actually know what is the property of our universe that has facilitated something that could go on for more than 1 billion years of creativity. We don't create systems like this. Like none of the domains or artificial systems we create have this property. You're just putting algorithms aside for a second. This is a fertile area for research to understand open-ended environments where the surface is still barely scratched. Thank you.
Thank you very much, Ken. Opening our minds to open-endedness. And that leaves the last speaker for the first panel, which is Yejin Choi, who is a professor of computer science at University of Washington. She just won a AI 20 Outstanding Paper Award, and she's been following her own hybrid approach, I suppose, using common sense transformers with good old-fashioned AI, trying to combine symbolic reasoning and neural networks, which is dear to my heart. And I really look forward to seeing what she can pack into the next 3 minutes. Take it away.
All right. So this should be fun. So why common sense? Because despite human level performances on leaderboards, today's state-of-the-art models are brittle and make such silly mistakes that humans will never make when provided with adversarial or out-of-domain examples. So the bottom line, we know how to solve a data set without solving the underlying task with deep learning today. And that's really due to the significant difference between AI and human intelligence, especially what Julia said earlier, that the knowledge of the world or common sense is one of the fundamental missing pieces. So common sense. The common misconception about common sense, by the way, is that it may be just some facts that everyone knows and agrees upon. If it's that simple, we would have solved already by just enumerating all of them. Here comes my key point, though, which is through this famous example, Roger Shepard's Monsters in a Tunnel. What you see here is not just some objects in a scene. You see a story that two monsters are running as opposed to standing still on one foot. Their intent being one is chasing another as opposed to trying to copy their body movements, and their mental states being hostile or being afraid, even though actually two faces are identical. These examples are from The Enigma of a Reason, highly recommended if you haven't seen that one. Anyhow, two important takeaway messages. First of all, none of these inferences is absolutely true. Everything is sort of causal and stochastic in nature, but diffusible with additional context. And also, a great deal of such inferences can be best described in natural language. Our causal reasoning is really deeply integrated into language, another point that Julia made earlier today. And so here comes the controversial remarks of the day, which is obligatory in a debate like this. So when we talk about language, neurosymbolic integration, I think we need to embrace language, the entirety of it, not just some words, which is the more commonly made assumption. And if you are not satisfied with my reasoning, that's also the point made by Hofstadter and Sander. And yes, that's the Douglas Hofstadter that you know about from another book. And so if you buy that, then reasoning really becomes a generative task as opposed to categorization task that we're more familiar with in today's deep learning benchmarks. And that's because the space of reasoning becomes infinite, and we got to really be able to deal with it. And the beautiful thing about human intelligence is that we can think out loud. We can oftentimes reason by just writing or speaking on the fly, word by word, without enumerating a million possible sentences that you could have said instead. We just never really enumerate very much. We just reason on the fly. And this is really going to be one of the key fundamental intellectual challenges that we can think about going forward. So only several years ago, when I started contemplating on research on common sense, I was told not to even speak the word because nobody would take me seriously. But then I realized the past failures are completely inconclusive when they were only based on weak computing power, not much data, and so forth. So path to common sense, it's a moonshot research, so we still don't know the full path yet. But one thing for sure, we cannot just get there by making the tallest building in the world 1 inch taller. Therefore, GPT 4, 5, 6 may not cut it. And we need to do like this whole range of different research programs, combining symbolic and neural representations, integrating knowledge into reasoning, and also constructing benchmarks, which are not just a categorization. Okay, so more stuff online. We gave the first tutorial on common sense this year at ACL, and I'll stop here. Thank you.
Thank you very much, Ajin. I will make some very brief remarks and then ask a couple of questions before we go to the next panel. So I see a lot of convergence in what people talked about today, which is great. And I think convergence should be the theme of the day. There was convergence on the importance of thinking through what evolution has to say to the story, on counterfactuals, which is a topic that Danny is going to pick up in his talk on the cognitive psychology of counterfactuals, I guess. There was a lot of emphasis on dealing with the unfamiliar and with open-endedness rather than just things we've seen before. Deep learning is very good with the familiar, but not necessarily the unfamiliar. There was a lot of convergence on the need to integrate knowledge. Judea made the point that data alone is not enough. We have to integrate it with knowledge in some fashion, which is also a theme in my Next Decade article. A lot of emphasis on common sense. Yejin was pointing in that same direction, and she used the word generative, and I think that describes a lot of the things that people have talked about. So I think it was a terrific session, a lot of different ideas. There's also, I think, a question of integration and pluralism. And this is the first question I'll throw out to the panel is, okay, we've seen 6 or 7 different perspectives on this. How are we going to put all of those together? Do we want to put all of those together? So can we make reinforcement learning compatible with knowledge, for example? Is that something that we should be trying to do? So Louis has raised a finger, and I'll let him be the first person to jump in.
Yes, neurosymbolic AI or neurosymbolic computing is not about the how. It's not an implementation detail. Neurosymbolic is about representation, not about the how. Representation, in a way, precedes learning. If one wants to have, for instance, what Eugene mentioned recently, what is common sense with causal implications. So it's very important to understand that we have the same aims at building something very solid in terms of computational theory, as Rich mentioned. Reinforcement learning, of course, plays a role in that, but we see that representation precedes learning, which is something that's very important to have in mind. It's not only about data, as Jude has been saying. I read all of his papers and books, but if one wants to have the aims and to pursue the objective that Rich has mentioned brilliantly, I think that one has to have in mind that in order to have effective neurosymbolic models or effective rich AI models, one needs to consider that proper knowledge representation reasoning and proper representation of the data and of the knowledge about the world precedes the learning procedures. And I have to stop here, otherwise other people will not speak, Gary. Thank you.
Who else would like to jump in? Or I can sharpen the question a little bit. And I'll sharpen it for Rich in a way, which is, do we want one computational model here in the Mars sense, or are we actually looking for a pluralism? So people who have argued for modularity, like Steven Pinker, have argued that there are many different modules with different adaptive specializations. So do we want to have a lot of different modules that have different properties, like a counterfactual reasoning module might work differently from a reinforcement model, or are we looking for a common framework? Rich, go ahead.
So I could speak to that, yes. Reinforcement learning is a computational theory. I'm arguing that it's the first, but it would be just the first. There could be others. And, I really would welcome that. I would welcome other things that proposals of alternate ways of thinking about the overall problem, not just the representations, not just whether it's learned or innate, but what is it? What is it? What is the overall thing that we're trying to achieve? And how can we tie that to the computational theory level should be coherent in amongst itself. It should constrain itself. It should be analyzable at that level, and it would be great. We need multiple alternate theories, computational theory.
And I'm going to read an audience question, or I'll adapt it slightly. A bunch of people who submitted online questions wanted to know, how do you work in causal frameworks when you have variables that are unfamiliar? And one case would be you want to reason about coronavirus 19 and you don't have it before, you don't have a pre-built system representing its causal relations to many factors. So how in that framework, and I guess this is a question for Judea or Robert, what do you do with new variables? How do you face them?
One thing I should introduce at this point is that what we found, it takes so little and such primitive relationship to get so much. Namely, sometimes you need only relations such as the drug doesn't change the sex of the subject, okay? To get terrific mileage in the kind of inferences that you can draw from it without a simple relationship, right? That the drug doesn't change the sex of the object. You cannot do things. And with this qualitative, primitive, commonsensical relationship, you can do so much. This was amazing, that you need such a only qualitative, simple relationship to get such a huge spectrum of ability. And that answer your question, what do we need for corona? Simple epidemiological relationship of how disease propagates and what relations are there between what makes certain sources of information reliable and other not reliable. Just qualitative information, which is not too hard to program, hand program, can buy you a tremendous mileage.
Robert, do you want to jump in there?
Yeah, I would say something along the same lines as with the example of Corona, of COVID-19. It's a coronavirus. Oftentimes, well, in this case, we were able to go and find computational models of other coronaviruses and build reason about them as causal models. And then as we're able to learn new things about this particular strain of coronavirus, we can update our model with that new information and make inferences. It's also a good example, I think, of my call to look towards more probabilistic programming techniques, because some of the more interesting models epidemics are from epidemiology. They're dynamic models like SIR models or SEIR models, and those are dynamic models using differential equations. And so you might want to represent that kind of dynamic process explicitly in code, and still be able to reason, say, for example, counterfactually about it, like what would have happened had we instituted a stay-at-home policy 3 weeks earlier? How many lives would we have saved? Things like that. Generally speaking, you encounter that a lot, where you hit a problem and you're unfamiliar with it, but there are abstractions that you can import from similar domains, and then as you go, you can refine those abstractions as new knowledge and new data come in.
Adrian, you must have thought about causality a lot in constructing the databases and so forth that you've been working on. Do you want to say anything about that?
Yeah, so I'll be a little bit controversial, although I'm also very much in line with what were discussed so far, by adding that some of the human causal reasoning is entirely flawed. I mean, we see that with the coronavirus as well, and climate changes, and humans are capable of believing strange things and do strange causal reasoning. Now, we need to make a very interesting decision here, which is that do we really want to build human-like intelligence, or do we want to somehow find the conjunctive subset of what is more desirable between AI and human? But I think still, even if there are weaknesses with the human intelligence, there's something really fundamentally interesting about causal reasoning that humans do, which oftentimes, by the way, nobody needs to define coronavirus as a variable for me. All the information that I get is ever transmitted to me in natural language. And I think this is really, really interesting capabilities that humans have in acquiring knowledge about how the world works. Without me actually being sick of coronavirus, I still learn a great deal about it. Even without interacting with it personally, I still learn a great deal about it just by reading language, textual descriptions. And I think this actually is one of the important challenges we need to address, including the nuanced and somewhat unsound causal reasoning that we do all the time. And these were actually key points that I was making in my pitch earlier as well, which is that when you reasoned that the two monsters are running as opposed to standing still on one foot, we just made erroneous inference that may not be entirely true. But that's really the gist of common sense causal reasoning that humans do all the time.
I have a question for Ken and Feifei, and then we'll go on to the next panel and Barbara. You both mentioned evolution, and there's been a history of people playing around with evolution and neural networks and things like that. Ken has done some of the seminal work there. What's the status of that field right now? Is that going to be a big part of the next decade now that we have large computational resources?
Okay, that's a big question. So yeah, when we called that neuroevolution, I think that the important thing about neuroevolution as a field within AI is whether we interpret it as sort of like a dogmatic push towards just using evolutionary algorithms, or if it's more viewed as kind of an attempt to understand why, like I mentioned in my talk, open-ended phenomena are so important and what allows them to actually perpetuate, which has sort of traditionally not been really what's been going on with, so if we evolutionary algorithms or genetic algorithms. And I think that caused some confusion about the motivations behind doing this kind of work. So we don't necessarily have this sort of dogmatic view, like you have to run evolution to get an interesting answer to something from a reinforcement learning perspective or something like that. but rather there are properties of evolution, evolution in nature, that are just so profoundly powerful and are not explained algorithmically yet, because we cannot create phenomena like have been created in nature. And those are properties that we should continue to chase and understand. And those are properties not only in evolution, but also within ourselves. As I tried to argue, there's a parallel between our own history of innovation and evolution. And in that sense, yeah, I think we're going to continue to pursue these kind of algorithms and also hybridize them with others, including learning algorithms, because after all, that is the world in which we live, where there's an outer loop of evolution and inner loops of learning.
Absolutely.
So-
Fei, I'll give you the last word in the first panel.
Wow, it's a big honor. So first of all, totally agree with Ken and love everything I've heard. So evolution for me is one of the greatest, probably the greatest experimental setting of the emergence of intelligence. But like Ken, I'm not dogmatic about it. I still hold the dream as a scientist, or maybe it's through my physics training, that there is going to be a set of unifying principles of intelligence, either through these principles have guided certain amount of animal intelligence emergence, but will also give machine intelligence. And evolution is one of the greatest, richest experiment we have seen, and there's so much inspiration. But I'm not dogmatic about following the exact environmental constraints and biological constraints of evolution. I want to distill the principle setups such as embodiment, interaction, multitask, and etc. So we'll continue to really draw a lot of inspiration from evolution, but that's not the end goal, at least not in my pursuit.
So it breaks my heart to have just told one of the panelists not to ask a question now, but I think we should do all three of our panels. So the next panel is going to be on insights from neuroscience and psychology. Let's see if some other fields can help us sort all this out. And we're going to start with Barbara Tversky, who's a professor emerita at Stanford University. She's a leading cognitive psychologist with a focus on visuospatial reasoning and events, although I don't see that in the bio here, and collaborative cognition. She's author of Mind in Motion, How Action Shapes Thoughts. Welcome, Barbara. You are muted.
Thank you. Thank you. And thank you for inviting me. The talks have been awesome, and I'm thrilled to be here. So all living things must move and act in space to survive, even viruses. When motion ceases, life ends. Unlike viruses, people act in space in a multitude of ways. They push, pull, tear, throw, kick, and put together. And those actions on objects become actions on ideas. We push them forth, we pull them, we tear them apart, we put them together. They also get expressed in gestures that are miniatures of the actual actions, but again, they're acting on ideas, not on objects. Gestures that accompany explanations change our thought. Participants watched a video explaining how a car engine worked. One set of people watched just gestures that showed structure. Another watched gestures that showed the action of the engine. Those who saw structure gestures created visual explanations like the one on the left. Those who saw action gestures deeply internalized the action and produced diagrams like visual explanations like the one on the right that clearly divides the process into 5 parts. It shows the action, explosions, mixing gas and oxygen arrows in very vivid ways. So over and above words, the gestures that we make change our thinking. The gestures that we make when we're thinking change our own thinking. This woman is alone in a room. She's reading a complicated description of an environment, placing many things in spatial relation. Watch her hands. She isn't watching them, but her hands are creating a model of what she's reading. The words have an arbitrary relation to meaning, but the model she's creating has a direct relation to meaning. She's not looking at her hands. The model is motor, spatial motor, not visual. When she does this, she remembers better. When we tell people to sit in their hands, they remember worse. And some say, I can't think without my hands. This works not just for environments, it works for mechanical systems, it works for complicated scheduling, it works for linear orders and many other types of knowledge. So learning, thinking, communication, cooperating, competing, all rely on actions and a few words.
Thank you very much. And I believe our next panelist is actually in the same room with you, which gives us one last video to change. We next have Daniel Kahneman, who is probably most of you know, won a Nobel Prize in economics. He's professor emeritus in multiple departments at Princeton, including, I just learned this, in the Woodrow Wilson School, in addition to in psychology. And he's also the author of the best-selling Thinking Fast and Slow. And every time I go to New York, I try to have lunch with him, and he always asks me hard questions. Maybe I'll get to return the favor today. Welcome, Danny.
Thank you. I was actually going to talk about counterfactuals and normality, but it was a small talk. I was going to talk to you about how people undo events, which turns out to be a kind of counterfactual that's not the same as causal counterfactual. But listening to the talks of the first session, I decided that I should do something else, slightly more ambitious, and I should talk about two systems. I seem to be identified with the idea of two systems, System 1 and System 2, although they're not my idea, but I did write a book that described them. And as quite a few of you know, we talk about the contrast between one system that works fast, another that works slow. Oops. But the main difference between System 1 and System 2, as I described them, was that System 1 is something that happens to you. You are not active. The thought that the words come to you, the ideas come to you, the emotions come to you, they happen to you, you do not do them. And the essential distinction that I was drawing between the two systems was really that one, something that happens to you and something that you do. High-level skills in my description of things were absolutely in System 1. Anything that we can do automatically, anything that happens associatively is in System 1. Another distinction between System 1 and System 2, as psychologists see them, is that operations of System 1 tend to be parallel, operations of System 2 tend to be serial. And I think that this idea of two systems may have been adopted more than it should have been. And it seems to have been identified, and that's what prompted me to change my talk today. It seemed to be identified with the distinction between symbolic and non-symbolic, where System 1 is non-symbolic and System 2 is symbolic, one that does the reasoning. And there is, I had a very similar view myself. When you look at what machine learning does, it reminds you of that black box that produces miraculously and quite fast, produces very complicated responses or responses in very complicated situations. But I think the mapping is actually seriously imperfect. So it's true that any activity that we would describe as non-symbolic, I think does belong to System 1. That system one, I think, cannot be described as a non-symbolic system. For one thing, it's much too complicated and rich for that. It knows language, for one thing. Intuitive thoughts are in language. The most interesting component of System 1, the basic component as I conceive of that notion, is that it holds a representation of the world. And the representation that actually allows something that resembles a simulation of the world. As I describe it, we live with that representation of the world, and most of the time, we are in what I call the valley of the normal. There are events that we positively expect. There are events that surprise us. But most of what happens to us neither surprises us nor is it expected. What I'm going to say next will not surprise you, but you didn't actually expect it. So there is that model that compares, that accepts many events as normal continuations of what happens, but it rejects some. And it distinguishes what is surprising from what is normal. That's very difficult to describe in terms of symbolic or non-symbolic. Certainly, what happens is a lot of counterfactual thinking is in fact system one thinking, because surprise is something that happens automatically. You're surprised when something that happens is not normal, is not expected. And that forces common sense and causality to be in system one and not in system two. So I wanted just to clarify the language a bit, that it seems to me that the association of system two specifically with symbolic, and system one with non-symbolic, I really enjoy hearing those two systems mentioned in conversations about AI, but I'm not sure that they're always used as precisely as they should be. Thank you.
That was a beautiful explanation. Clearest that I've heard you make that point. And I will now introduce Doris Sal, who is at Caltech. She's professor of biology there. She's an investigator at the Howard Hughes Medical Institute. And she happened to have won the MacArthur Genius Fellowship. That's not its official name, in 2018. And welcome, Doris.
Thank you so much, Gary and Vincent, for inviting a humble monkey neurophysiologist to this wonderful gathering, thinking about the future of AI. It's really been inspiring. So the title of my talk is The Importance of Understanding Feedback, or How the Brain Models the World, the key element missing from our current neuroscientific understanding. So I recently learned that in the very first paper on neural networks, McCulloch and Pitts already grappled with what they called nets with circles. They recognized that the brain contains feed-forward and feedback connections. And my central thesis today is that understanding the purpose of these feedback connections will be critical for both understanding and engineering intelligence. I'll highlight 4 specific instances where understanding feedback could help us build better AI systems. First, the biggest lesson machine learning has taught us is that learning is critical to wire up intelligent systems. Artificial networks learn through backprop. How does the brain learn? And could this provide a new mechanism for learning in artificial systems? So one beautiful idea for how learning can occur in the brain is through predictive coding. And the scheme provides a means for unsupervised learning, since now all you need to do is predict your input image. And it also generates an explicit error signal locally within each area that can drive synaptic weight changes without the need for propagating error derivatives. Second, understanding feedback may allow us to build more robust vision systems by enforcing consistency between discriminative and generative models of the world. For example, if you think that you're seeing the letter 7, you can try to regenerate the image and check if it agrees with the actual image. Third, I think understanding feedback is the key to understanding the binding problem. Namely, how does the brain link representations of the same object across different brain areas? This is a foundation for symbolic reasoning, and understanding the brain solution may give us insights into how to build it into machines. And finally, understanding feedback will let us understand the mechanism behind mental imagery, hallucinations, dreams, and other strange psychological processes that have been suggested to relate to our creative abilities. Incorporating these processes might result in more creative AIs. And Mother Nature has handed us a remarkable gift for understanding cortical feedback to the macaque face patch system. This is a set of regions in the macaque brain dedicated to processing faces. And it has 2 properties which make it ideal for understanding the function of cortical feedback. First, it constitutes a hierarchical network of nodes connected through both feedforward and feedback connections. And second, we understand reasonably well the representation used by each node, which is a prerequisite for understanding the function of feedback. Because even if we could record from feedforward and feedback neurons separately, if we didn't understand their representations, we'd have no idea how to compare their activities. And finally, we recently showed that the face patch system provides a model for a vast swath of IT cortex. So whatever we find for the face patches will likely generalize to all of object vision. And I don't know what we will find, but I think that figuring out the function of the feedback pathways in the monkey visual system is going to reveal important constraints for how to optimally incorporate feedback in artificial systems. And I'm very excited about the exchange between machine learning and systems neuroscience towards this goal. Thank you.
Thank you very much. Our next speaker is Adam Marblestone, who is a Schmidt Futures Innovation Fellow. He's a former research scientist at Google DeepMind. He works on connections between AI and neuroscience. And I will just say that writing a paper with him called Atoms of Neural Computation, was in Science in 2014, was one of the most stimulating projects of my career. I welcome Adam Marblestone.
Thank you, Gary. It was one of mine too. It was around the holidays, around 2014. I recall if we were working on that. So I would describe myself as a maximalist in terms of ways that I think neuroscience and cognitive science can impact AI. So I don't intend what I say to be exclusionary to any of what anyone else is saying here. And I also think that this is only part of the picture, and that computer science and pure AI approaches also have a lot to say. But what I want to do in this talk is just highlight one area of neuroscience that I think may be emerging to have the potential to impact AI, but has so far been kind of neglected for lack of data and just because there's been very few papers actually trying this. So the conventional perspective, if you will, if I can call it that, on how neuroscience would inform AI is this idea of getting mechanistic insight from neuroscience. And this, I think, is reflected in the last talk on feedback and the face patch system. But the basic idea is make observations of the brain, try to abstract that to a theory of functioning of different circuits in the brain and how they work. Right now, we're at a fairly primitive ability to do this. So we have many different theories, even looking at the same cortical microcircuit structure, which is only now partially being understood or even measured. That same theory, that same data, such as we understand it now, can map onto, depending on who you ask, a number of different ideas: graphical models, biological implementations of backpropagation, what Gary and I were writing about is sort of modular, reconfigurable circuits, or some people maybe think that it's actually not. It's hopeless to actually figure this out. So there are a number of possibilities. I think as we get deeper data about this, they will start to make more unique predictions that will be more falsifiable. But what I want to do is connect this back from this kind of mechanistic neuroscience view to something that maybe connects more directly to how deep learning researchers think today and conduct research today. So with a few exceptions, I would say in deep learning research, many of the impressive kind of real world examples like image classification or rich natural language, they come from using big human derived data, basically copying human behavior, whether that be copying human choices as far as classifying images or copying the utterance statistics of natural language in something like GPT-3. And recently, in some cool papers from DeepMind, for example, copying or doing what's called behavioral cloning on interactions between humans as one human is teaching another human to interact in an embodied setting. All of these rely on human behavioral data as a key component of the training. There are some exceptions now where you don't rely on any human data, where you're trying to bootstrap entirely using reinforcement learning. Amazing one in Nature this week where they're doing model-based reinforcement learning with a learned model on Atari. That's an amazing example where it doesn't really use human data. But what I want to suggest is that there's an aspect of neuroscience that hasn't been used as a source of data for directly using that as a supervision signal or training signal, and that is the actual brain activity itself. So what's shown on the right here is from now almost 10 years ago, Jack Gallant's lab at Berkeley taking fMRI activity patterns in the human brain and using that to decode what image the person is looking at. That's a big, expensive MRI machine. Meanwhile, there have been developments in making brain activity scanning in humans much more accessible, portable, cheap. What if we could actually directly use the human brain activity as a teaching signal, where we say, when I look at an image, not only do I match how that person classifies the image, is it a dog or is it a cat, but I actually directly try to make the AI predict the full activity pattern in that person's brain. Could that be used as a source of a dense teaching signal coming from neuroscience? And there's only a handful of papers about this, but I'll point you to the one from David Cox's group, where they were using human brain activity to guide image classification algorithms. So thanks a lot.
Thanks very much, Adam. Our next speaker, the last one for this panel, is Christoph Koch, who's the president and chief scientist of the Allen Institute for Brain Science in Seattle. He's also done a lot of work on consciousness and written several books, some of which are on consciousness, including Consciousness Confessions of a Romantic Reductionist. I always love that title. And also the amazing book, The Biophysics of Computation. In addition to all that, he's co-written several articles with me, including my one and only published science fiction essay. Little known fact about Christoph. Welcome, Christoph. You're muted.
Yeah. Okay.
Don't see your slides though.
How about now?
They're beaming in. Now we see them. Yeah.
Okay. Yeah, so I'm here at the Allen Institute, which incidentally is not the same Allen Institute that Ye-Yin Choi talked about. We're both started by Paul Allen, but we're the Allen Institute for brain science. We face each other. We are in view of each other, but we're independent institute. So we focus on biology, and over the at the Allen Institute, we carry out these very large-scale foundational surveys of the anatomical, genomic, and physiological architectures of brains. Particularly, we focus on the brains of mice, of monkeys, and on human. And all this data is published in high-impact journals and made freely and publicly accessible. So the point I'm trying to make here is that these massive resources reveal brains made out of amazing complexity, none of which is reflected in any machine learning models or in any of the current models of AI. What this reveals, including the connectomes that we are now getting, both the complete connectomes of cubic millimeters of tissue, both in the mouse and in the humans, they reveal that these brains are not only made out of millions or billions of neurons and glia cells, not just excitatory and inhibitory cells, but a fantastic, just a mind-blowing variety of cell types on the order of, now we estimate 1,000 different cell types, neuronal cell types, that differ by their developmental origin, that differ by the genes they express, the layer in which their cell bodies is located, which is critical to understand anything in cortex, the addresses they send the information to, that differ in the synaptic architecture, in their dendritic trees, in the electrophysiological functions, etc. So we have, highly heterogeneous individual components, roughly 1,000 times, that combine both the functionality of computation and memory, so very different than our current, VLSI hardware, into these densely interwoven networks with fan in and fan out on the order of 10,000. All right. So this really exceeds anything that science has ever studied, with these highly heterogeneous components on the order of 1,000, with connectivity on the order of 10,000. As I say, the brain is the most highly organized piece of active matter in the known universe. And if I look at the state of the art, deep neural networks, they're really very impoverished, and they're very impoverished. So by and large, they have, halfway rectified or, gain control saturating units. So 2 or 3 different types compared to 1,000 different types that we see in the brain. And of course, as Doris also emphasized, the vast majority of them are essentially feed forward with maybe some weak feedback. In the brain, with the possible exception of the retina, there's nothing that isn't massively feedback, not only weakly modulated, but massive feedback. And so understanding brains and their pathologies is a project probably that's going to take us a century or 2. We believe now it looks like if you look at pathologies like neurological diseases or psychiatric diseases, they're very often pathologies of individual cell types. And so that's why the sensors of these different cell types across all mammals, because it turns out they're very similar, whether you're looking in a mouse, a human, or a monkey cortex, you can identify sometimes one-to-one matching cell types in the mouse, in the monkey, and in the human. So understanding brains and their pathology is going to take a very long time, much longer than the time scale that AI in the industry is operating under. And there's this illusion of we have this exponential growth in neuroscience data, but that really obscures the underlying sublinear growth in our understanding of the principles of brain science. I'm not talking about cognitive science. I'm not talking about developmental psychology or psychology in general. I'm really talking about the physical substance of our minds, either the brain. And the dirty secret of my field is that we don't like to talk about. We have a connector with a complete wiring diagram of C. elegans since 1986. Okay, that's a third of a century. There's still no general purpose integrated model of its 302 neurons, right? And here we're trying to understand the 16 billion neurons that make up the human brain. So I think it's a mistake to look for inspiration. And so here I differ from my immediate predecessor, Adam, to look at the mechanistic substrate of the mind, the brain, to help speed up AI. I think that's a mistake. That's a mistake because the constraint that biology had to operate under, metabolic constraint, developmental constraint, evolutionary constraint, it's just radically different from the constraints that an engineered artifact operates under. And we don't really understand the relationship. If I look at across species now, we don't really understand the relationship of intelligence. How does it change? How intelligent is something? Because we don't have a good definition that only have 302 neurons, like a C. elegans, but that's been around for several 100 million years, compared to the intelligence of a bee that has a million neurons, compared to the intelligence of a mouse that has 100 million neurons, compared to the intelligence of Homo sapiens that has on the order of 100 billion neurons. Or even if we look within a single species, like humans or dogs or mouse, it has been done in these species, trying to ascertain some measure of intelligence, like the generalized G factor or IQ factor, things like that, and how that changes across variability in number of neurons, mass of the brain, thickness of cortex. We don't really understand that at all. And so there are these weird puzzles that Neanderthal had a bigger brain than we had, but we were supposedly their superior, we survived and they didn't. If I look at the brain of pilot whales, their cortex, not just the entire brain, but their cortex is twice as large as our cortex. They have 37 billion cortical neurons compared to our 16 billion cortical neurons. So why are we the dominant species and not these pilot whales? So I think we need to look towards psychology and cognitive science and developmental psychology for inspiration that'll help further power. Brains primarily provide existence proof that adaptive intelligence is possible in physical hardware.
Thank you very much for that provocative talk, Christoph. It's kind of a note of intellectual humility for the entire field, which I appreciate.
Unusual, I know.
I will make a personal remark and then ask some questions. The personal remark is I have always felt like we will figure out AI before neuroscience. I think, I'm well known for my skepticism about AI, but I think you're making measurable progress, if slow there. And neuroscience just seems so hard. And I think we're going to need computers' help in order to understand all the data once we even figure out what the critical data are. So here's my first question. I'll start with the neuroscientist and then I'll go to the psychologist. For the neuroscientist, at least Adam and Christoph know the paper I wrote with Adam, and I don't know if Doris knows it or not, but the contention of that paper was that the quest for a single canonical cortical circuit might be a mistake, and that we might be ought to be looking for greater diversity. In, maybe there's not just one column circuit that's identical everywhere. And the empirical data, I think, has been relatively charitable to what Adam and I have said, but I haven't followed it that closely the last few years. So I noticed a hint of that in Doris is saying, if we figure out this piece of visual cortex, it'll tell us a lot about other pieces of visual cortex. How far would you like to take that, Doris? And I'll take Christoph and Adam after that. Like, do you think that's going to tell us anything about prefrontal cortex, or do you think the boundary is there?
Yeah, I think if you look at the structure of the brain, one piece of the brain really looks physically like another piece, right? The 6 layers, the cell types, there's some variability, but overall what really strikes you is the similarity. So I definitely think that there's, some really deep general principles about how the brain is organized that, transcend whether you're in visual cortex or auditory cortex, and even between sensory and cognitive parts of the brain. And, I think, for example, predictive coding is this really, this normative model that can explain many, many things, right? Like unsupervised learning for all kinds of abilities. So, there's undoubtedly going to be differences, but I really think like seeking this general principle is going to be very powerful.
Adam?
Also, I have to agree and disagree with Doris. Yes, there's similarity. So in both visual cortex and prefrontal cortex, they are focused on pyramidal cells and interneurons. But if you look at actually the cell type as determined by single cell transcriptomics or other measures, they're quite different. Visual neurons do not map onto neurons in prefrontal cortex. In that sense, they're different. So, and those differences are probably significant. How important are they to understand computation? That remains to be shown. We don't know.
Adam?
Right. Well, I don't want to claim an answer. I think if anything, from when we were writing that paper, Gary, since writing that, I think my view on the possibility that there would be unifying, if you want, learning principles, rather than a need for a sort of a very diverse set of modular bricks, computational bricks, has maybe moved more towards the idea of universal learning algorithms as I spent more time interacting with the AI researchers. But I think that the point is we need to get better data, and I hope it doesn't take a century to figure it out. But I think it will take some time to understand empirically, the computational significance, as Christoph said, of these differences that you do find. So.
Good thing I wrote that paper with the Adam of 2014. Then. All right, question for the psychologist. I realize as we're doing this, and realized a few days ago, we don't have as many developmental psychologists here, although Celeste is one. I'll throw this question out to her as well, even though she's in the third panel. The big developmental question is always about innateness, and I'm going to ask some specific forms of this for Danny and Barbara, and then maybe Celeste will join in. Danny, one of the things you're not as famous for is the System 1 and System 2, but I think has profoundly affected cognitive psychology is the notion of object files that you did with Anne Treisman. And the way I've always sort of caricatured that is you have to have an index card in your head for each of a bunch of things that you're tracking. And they're kind of like files for events. These properties are there. And I've always imagined those to be innate. Have I recapped the notion correctly? And do you think of this as an innate architecture or something that's learned? And you guys are muted.
Well, object files, the idea of object files was when you track an object, it can change, and yet it remains the same object. And there is a given number of objects of object file that we can retain or at the same time. By the way, the notion came from police file. I mean, the police opens a file for a case, and then the content of that file keeps changing, but it's the same file. And the number is quite limited, and I do believe that idea of maintaining objects is surely innate. Hard to imagine how it could be otherwise. Innate.
In standard kind of deep learning architectures, there really aren't the equivalent of object files where you can accumulate properties about an entity over time. There are various workarounds, but that's always struck me as an issue. And there's a whole chapter in my book, The Algebraic Mind, is actually built on the object file idea and type token distinctions. Barbara, my version for you is, how much of a Kantian are you? So Kant tried to argue that time and space, I don't remember what he said about events, it's been too long, but at least time and space, he argued essentially, psychologizing him, were innate. Are you down with that? What's your view? You've thought a lot about representations of time and space. My guess is you think some of them change over time, but some are innate, am I right?
So I have trouble with innate. I even have trouble with object files being innate in babies because of object permanence. It takes a while to learn that an object that goes behind a barrier is the same object coming out. So it feels to me like I'm uncomfortable with that sharp dichotomy between what's innate and what's acquired, because so much of what seems to be innate depends on experience. Feifei talked about Held's work with the two kittens. And to develop visual learning, you need to act in the world. So I'm never sure what is exactly meant by that's innate. And maybe you can clarify that a bit.
I saw Celeste wrinkling her nose at the same moment I wanted to, so I'll let Celeste go first.
Yeah, so I echoing the points that Dr. Kahneman and Dr. Tversky made. I also have a little bit of a problem making sense of what it means for it to be innate. I think we have ample evidence that infants' attentional systems are ready to handle objects very early. I wrinkled my nose a little bit on the infants learning object permanence, because while I do think there's a lot of evidence that it takes a while to learn various properties of objects, we're also limited in terms of what we can detect that an infant knows. And as we've developed new methodologies that depend on gaze, what we continue to discover is that infants are actually capable of understanding a lot more about objects than we used to think. One point that I wanted to add on to everything that's already been said is that an alternative to sort of the object files type of theory is something that is more maybe bandwidth. You could think of it limited. I'm thinking of work by people like George Alvarez and Ed Vull suggesting that there is an upper limit on how much information you can process in a moment, but that it's not specifically strictly tied to the number of objects. The number of objects you can track depends upon things like the complexity of the objects and also how rapidly they're moving. So yeah, that's it.
All right, in the interest of time, I'm going to go to the third panel, and then we're going to have fun when everybody joins at the end, sort of like at the end of a rock concert. And so we can continue some of those discussions then. But Celeste is actually our next speaker in the third panel, which is called Towards AI We Can Trust. And I think, there's a set of constraints on how we build our AI in terms of we want them to be open-ended and flexible and so forth. We also want them to be ethical and trustworthy. And Celeste is going to lead off this panel. She's a professor at UC Berkeley. She was among the silence breakers who were named Time Person of the Year in 2017. And I think her work on belief formation is critical in the current world that is inundated with misinformation. So take it away, Celeste.
Thank you so much, Gary. Thanks for the introduction. That is what I'm going to talk about. My lab at UC Berkeley studies how humans form beliefs and build knowledge in the world. In particular, we focus on how humans navigate the vast seas of all the possible information that they could try to make sense of in the world. Sorry, little delay. The thing that I'd like to emphasize today is that algorithmic bias is not only problematic for the direct harms that it causes, but also for the cascading harms of how it impacts human beliefs. This is problematic because there are systems interfacing with people every day, embedded seamlessly in our lives. These systems drive human beliefs in sometimes destructive and likely irreparable ways. What our research has shown is that people don't learn deeply about most things. People have to make up their minds quickly in order to act. And once a person has made up their mind about something, they don't easily revise. Cognitive mechanisms kick in that dissuade them from revisiting the same topics, likely in the interest of focusing instead on new things. With that knowledge about how people work in mind, now consider content recommendation AI. Content serving algorithms on news and social media recommend content based on likelihood of user engagement, thus leading users to see content that espouses homogeneous and sometimes rather wild beliefs. This is especially problematic when users go to these sources while they are unsure, in order to collect information that they're going to use in order to make up their minds. These systems run the risk of pushing users towards stronger, inaccurate beliefs that, despite our best efforts, are very difficult to correct. Here's just one more example. Amazon and LinkedIn have both been caught employing technologies that promote men and filter out qualified women job candidates. But the harms went beyond just the particular women in these pools. These systems almost certainly impacted the beliefs of the recruiters that were using the systems. If their searches didn't turn up qualified women, they likely concluded that qualified women didn't exist, when in truth, it was a bias in the applicant selection system. The point here is that biases in AI systems reinforce and strengthen biases in the people who use them. I want to close by saying that right now is a terrifying time for ethics in AI. The termination of Timnit Gebru from Google marks a dark turn. Even after Me Too and the 2020 Black Lives Matter protests, it's clear that private interests will not support diversity, equity, and inclusion. It should horrify us that the control of algorithms that drive so much of our lives remain in the hands of a homogeneous, narrow-minded minority. What Timnit experienced at Google is the norm. It's hearing about it that's unusual. It's also, unfortunately, the norm that people who speak about inconvenient truths to power are discarded. They're quietly pushed out by institutions like Google, who, if caught, pretend that people like Timnit did something wrong. This manipulates everyone's beliefs into thinking that underrepresented people are underrepresented because they cause trouble, not because institutions themselves discriminate. But you should listen to Timnit and countless others about what the environment at Google was like. Jeff Dean should be ashamed. The rest of us have a responsibility to see this for what it is and insist that it stop. Thanks.
Thank you very much for that. And I had really hoped to have Timnit here today, but she's obviously busy with a lot of things. Right. But the next best thing to having Timnit here is Margaret Mitchell, who is at Google and who was co-author with Timnit of a paper very relevant to all of that on large language models, also with Emily Bender. And that paper was just accepted yesterday, and I think this would be a great opportunity to hear a little bit about what's in it. So welcome, Margaret.
Yeah, and hopefully you guys can see everything okay. I'm Margaret Mitchell, otherwise known as Timnit's co-lead at Google, and I'm going to be talking a bit about what we were up to that has gotten us into this mess today. The sort of typical approach to developing machine learning systems uses the sort of four-tiered model where you have training data collected and annotated, then the model is trained, media then can be filtered, there's post-processing steps, and then people see the output. But rather than this sort of clear pipeline that can just be applied by engineers without sort of further consideration, there's human bias coming in from the very start. So this is things like racism and sexism already inherent in the data that we're collecting. And then there's further bias in how we collect that data, where we're sampling the data from, and how we're getting things annotated. And this propagates throughout the rest of development. It's not undone. It further affects model training. And then further in model training, there's further biases and value decisions about what's worth prioritizing on and what's worth not prioritizing. So for example, what loss function you use is putting in a value statement of what is worth doing well on and what is not worth doing well on. There are then human biases in how things should be post-processed or generated, And then people see the output and start to act on that output. And to Celeste's point as well, this then becomes a feedback loop. As you see more and more models confirming your pre-existing beliefs, you hone in on those beliefs more and more, and then create more data that then is used to train further models, really creating sort of polarization around different human biases. So we were trying to break this system. We call it bias laundering. I'm really excited to share this slide because it has this awesome graphic I'm very proud of. But the main idea that what we were focusing on is that development is value laden, and there's no such thing as neutrality in development. There's not this idea that like algorithms are neutral or programming is apolitical. Everything packs in human biases and different value judgments. And the difficulty is that the different kinds of decisions that are made will affect different people differently. And so one of the fundamental parts of developing AI ethically is to make sure that from the start, there is a diversity of perspectives and backgrounds at the table. So defining what the problems are, what needs to be looked at, as well as things like how to collect the data. So people who are deeply affected by these technologies are often not considered as part of the development process. And this is one of the things that we've been trying to work on operationalizing. So how do we do this? So one of the approaches here, there are lots of different approaches, but one of the ways that we've been approaching this is in terms of breaking down the space of development into the different factors involved in that development. So there are different things at play, right? There's like the model you're using, there's like what you're thinking about that you want the model to do, there's the data, there's all this stuff, right? And so we've been working on frameworks to coherently go through all of these different kinds of considerations in order to make clear what things are already being packed into system development, with the hope that once you can, reflect on all of these deep, nuanced details, you're able to develop in a more informed way, working towards foreseeable benefits and not being hampered by foreseeable harms and risks. And so getting into this requires things like articulating what harms and risks are, right? It's very difficult for tech to do this. Tech as a whole generally is very good at benefits, extolling the benefits and solutions of tech. And so one of our sort of unique contributions in this space was to do things like honing in on different foreseeable harms, foreseeable risks, and tying it to the long-term effects of different models. So recently, there has been particular concerns around language models. OpenAI released a couple language models that were massively powerful, generating large spans of fluent natural language. Gary talked about this in the opening. And we consulted with them. They ended up doing this model card framework thing that we had been developing. But where we got stuck was, well, we know there are issues, but what are those issues, right? We want to talk about potentials for misuse, but what is the source where we find those things? So one of the endeavors that we had been working on was articulating specifically harms and risks. So this is sort of neatly fitting within the overall paradigm of ethical processes, or how you operationalize ethics and development, focusing in specifically on the subtopic of harms and risks, thinking about the general purpose models, language models, and detailing the harms and risks therein. And then this ended up just very recently getting Timnit fired. I am also an author on the paper. Timnit and Emily Bender are co-first authors. But you wouldn't think it would be that radical to put foresight into a development process. But I think we're seeing now just how very serious that is, and just how little value companies are placing on the expertise and backgrounds of their workers. So one of the key things that I've been working on, that Timnit has been working on, that we're really trying to push forward in the ethical AI space is the role of foresight and how that can be incorporated into all aspects of development.
Thank you very much. Our next speaker is Francesca Rossi. She is an IBM fellow and AI ethics global leader. She's a board member of the Partnership of AI. She's the AAA president-elect. She's a leader both in some hardcore technical work on constraint satisfaction and also in AI ethics. And I once had the pleasure of co-editing a special issue of AI Magazine with her on Beyond the Turing Test, and I hear that she is trying to punish me by making me co-edit another special issue.
Yes.
Maybe she will talk me into it.
So you just committed. Yeah. Okay, thanks, Gary. Okay, let me tell you about my experience, in dealing with trust and AI ethics in general, and also what I think are some main points. So some of them are technical and some of them are not in really achieving this ecosystem of trust around AI. So this is the overall picture that I think that many of the previous panelists put forward. We want a future, I would say, of and with AI, because of course I don't think as AI at AI as just autonomous systems, but also systems that work with us. So it's not just the future of AI for me, but also with AI. And it has all these desirable properties. Of course, trustworthiness is one, but of course, general collaborative, and as already mentioned for GPT-3 and language, very huge language model, also sustainably and computationally. But how to focus on this third panel? How do we build an ecosystem of trust? And I talk about an ecosystem of trust because it has many dimensions, just like trusting other people has many dimensions. So of course we want AI system to be accurate, but beyond accuracy, we really want a lot of desirable properties. One of them I called it, and some other people call it, value alignment, which is around fairness. How do we want these machines to behave? To behave according to some values that we care about. One of them, of course, is fairness. So we want bias to be identified, removed, and so on. But it may be other values that are beyond fairness. Robustness also, generalizability beyond, some data distribution, and explainability. Explainability is very important, especially in the context of machines that work together with human beings. Differently from what we would expect in building trust with another human being, here we are not in the presence of another human being. We are the presence of AI systems that are created by human beings. So just like Margaret and others have said, we want something also from those that create that AI system, from the developers, from the deployers, for those that use the AI. And one of the things that I think Margaret pointed out very clearly, and we have a very similar approach, is we want transparency. We want transparency about the decisions that have been made during the AI pipeline, whether they're decisions about the training data or other decision. And in that very nice visual way, Margaret showed that bias can be injected in many different places in the AI pipeline. We don't have the concept of a model card, but a very similar one called the AI fact sheet. And in fact, we work together with Margaret and others also within the Partnership on AI to compare and learn from each other these different ways to achieve transparency. The second point that I want to make is that, of course, we want these developers also to work according to some AI ethics and guidelines and principles, but principles are just the first step in a corporate place where AI is being produced and deployed. So it really needs a lot of multi-stakeholder consultation, education, training, and as Margaret already mentioned, diverse teams, to bring all many different backgrounds. It needs a lot of technical tools, for example, to detect and mitigate bias, to generate explanation, and so on. It needs a lot of work in helping developers understand how to change the way they're doing things, how to make it as easy as possible to adopt the new methodology, and how to build an overall governance in a company within, that is a kind of an umbrella over what developers are doing, what the business units are doing, and so on. So it's really a process. And that's why I put this picture of trust with all the cranes, because it's a process to build trust in AI. So the last point that I want to make is that for all these properties that we want in the AI systems in order to be able to trust them, unfortunately, current AI is not there yet, does not provide all that we need to make AI trustworthy. And many of the capabilities that we have been discussing in the previous panels about advancing AI, just not for the purpose of being trustworthy, are also very important as essential to make AI trustworthy. So, for example, neurosymbolic AI has been considered already, has been talked so much, as well as System 1 and System 2, that I agree completely with Danny, is not neuro versus symbolic, because so it's the neuro AI is lacking a lot of System 1 capabilities, but that machinery that we use in human beings is important to be able to model and embed human values in a machine, or to understand how machines can follow different ethics theory, like more deontologist, or more consequentialist, that are more, on the automatic, or more on the considerate and deliberate thing. Causality has been mentioned already, essential for explainability, for having interventions rather than just prediction, which is needed if you want to work with the between human beings and machines in a trusted team. Explicit knowledge, high-level concept. Otherwise, we cannot share within team members, the knowledge and communicate at the right level. Epistemic planning and reasoning, if you are in a multi-agent team environment, as well as introspection, metacognition, to achieve the kind of global reasoning that is needed to be also general, models of the worlds, others, and self, that has been mentioned already. That without that, we cannot have adaptability, generalization, and so on, as well as modeling a human reasoning models, not really for the purpose of replicating human beings, but really for the purpose of being able to work well with a human being in a team. But as was said already very explicitly in the previous panel, human and machines are very different platforms. They have very different embodiments. So it's not that clear that what works for, what enables the kind of reasoning that we see in human beings is the same thing that will enable it in a machine. So that has to be understood better, or at least tried and tested. And as I said, System 1 is really not just ML, and System 2 is not just symbolic AI. So that is also another big difference. So we really need to define what System 1 and System 2 is in a machine in order to understand how to achieve the desired human capabilities and we want in a machine as well, to be trusted. So overall, I think that the message is that it has to be very multidisciplinary approach, but also very multi-stakeholder approach to hear all the voices. Thanks.
Absolutely agree. And our last speaker of the day is Ryan Callow, who's maybe the only person here I have not met before, but I've been admiring some of the stuff he's posting on Twitter. He's one of the first people I noticed as a legal scholar to really dive deep into AI. He's a professor of law at UW. We have a lot of representation from UW today at University of Washington. Welcome, Ryan.
Thanks a lot. Okay, so so this is a very knowledgeable and sober-eyed group. But if you listen closely to many proponents of artificial intelligence, you begin to hear a kind of a paradox. And it's that AI is going to change everything, but nothing should change. That is, AI is going to fundamentally remake society, healthcare, finance, education, but there should be next to no change to law or legal institutions. In fact, such a change might be ruinous. So how do we explain this? Well, as these same proponents point out, AI is not a single thing. It's not an artifact like a train or a railway station. Rather, AI is a set of techniques aimed at approximating some aspect of human or animal cognition using machines. You can't regulate AI as such. So instead, the thought runs, what we need to navigate this sea change is a common understanding of values. In other words, we need principles. Well, I think we have someone else unmuted. It's commonly said that we'll get AV right before AI. So the thought is that we need principles, and you just heard Francesca talk about principles. Indeed, principles abound. Everybody has them. Governments, industry especially, NGOs, but also religious organizations, grassroots organizations, principles are everywhere. So I have a few problems with principles. First, to the extent that they draw their force from ethics, ethics is famously contestable. Both Bentham and Kant, though they had dramatically different moral systems, get to say should. Second, principles are not self-enforcing. No tangible penalties attached to violating them. You violate the law, and you lose money, property, maybe your freedom. You violate an ethical principle, and you get criticized on Twitter. But fundamentally, my view is that principles are largely meaningless because in practice, they are designed to make claims that no one seriously disputes. Does anyone think that AI should be unsafe or inequitable? And if so, are principles going to change their mind? So I don't think we need principles to resolve the paradox that I'm describing. I think what we need to do at this point is roll up our sleeves and assess precisely how AI changes human affordances, what people can do and how they can do it, and then adjust our system of laws to this change. Merely because AI can't be regulated as such doesn't mean that we cannot or should not change many aspects of the law in response to it. And I have a lot of specific ideas like along those lines of it. That's what I research. I research precisely what about law and legal institutions ought to be changing. Now, there is, of course, another alternative. We could just stop taking claims of AI revolution seriously. That is to say, we could say that AI is not such a big deal, in which case, of course, human law can afford to safely ignore it. But if we're serious about AI changing everything, or even a lot, then I don't think it's just a matter of principles. I think it's time to get work on rules, and otherwise that people won't ultimately trust AI enough to realize its benefits. Thanks.
Thank you very much, Ryan. My own view about ethics in AI is that it has to start in part, and I like the way Francesca put this, with some technical innovation. So there has to be all of the stakeholder and ecosystem stuff that I think we heard excellent arguments for, but there also has to be some technical advances for it to have any hope. So if we just use big data alone without knowledge, to borrow something that Judea said very nicely earlier, I don't think we can make it work. You think about Asimov's principles, do no harm. You need to compute what harm is in order to even get off the ground. And my day job now is running a robotics company, and many of the same issues come up for us. So we need transparency, we need reliable, deep understanding, to use the term that Judea and I both like. You need to have those things in order to even get off the ground in robotics, and you need them to get off the ground, I think, in building an ethical system. Part of what Ryan was saying is kind of a Pandora's box. I think the box is open now. My view is we're actually in the worst moment in AI history in a certain sense, which is we didn't have to deal with AI and all the biases and so forth 40 years ago because there wasn't really any. And I think eventually we can solve these problems. We can build systems that can reason. I think ethics is a form of reasoning. And we will be able to build that. But right now, we have these systems that are basically slavish to data without the knowledge. And that makes them dangerous. And so I think we do need to have regulations for that. Regulations might need to change as the systems become more sophisticated. But right now, they're not. We certainly need all those ecosystems and so forth. So I thought this was a terrific set of talks that dovetail nicely. One thing that is missing, if I can put somebody on the spot, is originally had Yejin in this session and moved her up to the first session. I went back and forth, but she's also done a lot of thinking about benchmarks. And part of what we need to do to get to ethics, I think, is actually to take a path through common sense. So you can't reason about, would it be okay if I did this or that to this person, unless you can reason about their intuitive psychology and physical reasoning and so forth. And to get there, we need to have some reliable way of at least measuring our progress towards common sense. Yejin, can you talk just a little bit about how you think about that?
Yeah, sure. I've been actually revising my thoughts a lot. So as you or at least Gary knows, I made quite a few benchmarks within a year, like 8 or 9 of them, depending on how you count, including counterfactual reasoning, a word that popped up often in this panel. And by the way, it's probably a bit different from the kind of counterfactual reasoning that some of the panelists might have assumed, in the sense that minds are really all based on language. Abductive reasoning, diffusible inference. We've been looking at all these non-monotonic reasoning challenges in AI, all through done in natural language. And in doing so, I realized whenever we frame the benchmarks as multiple choice questions, what happens is that leaderboard achieves, the neural networks achieve human performance on leaderboards without actually solving the task. Why is it that? It's because the framework of learning doesn't make any sense whatsoever in my mind. So I'm going to say something totally controversial, but I think that there's truth to it. Imagine as a human trying to learn about deep learning, and the professor doesn't teach anything. The professor just give you lots of multiple choice questions to study. There's no lecture, no tutorial, no textbook whatsoever. You're just given a lot of exam problems, and you try to learn deep learning for the first time in your life by reading, solving these exam problems. Now, some deep learning people say that self-supervised learning is the way to go. So forget about multiple choice questions and supervised learning. Let's do unsupervised learning, self-supervised learning by looking at lots of Python code or deep learning code. The thing is, well, if you already know how to read the deep learning code, Python, that's cheating. I'm going to give you a code, lots of code written in Korean language, a new programming language that you've never seen before. And as a human, I don't think self-supervised learning will succeed at all in learning anything. So the truth about the current deep learning paradigm, although I'm a big fan of deep learning and everything that I do does use deep learning as a subcomponent, I think it's just wrong. And so the benchmark, I believe, will have to be set up in a more generative way, which is alluded in my talk as well. So, human intelligence, you don't really believe in SAT or GRE in order to accept PhD students, nor do we decide who's going to get Turing Award based on that either. So there's something about this generative quality, ability that human intelligence has, which if AI is going to become closer to, I think we need to really test the quality of intelligence generatively. And so right now, GPT-3, all these, failure examples with the GPT-3 is implicitly of that nature. Gary was showing some examples where you make GPT-3 say something, then very quickly it says all this nonsense, incoherent narratives that we would never make. So stop there.
All right. My original plan was to have a discussion in this panel and then a larger panel, but the ethics and so forth connect to so many people in so many ways that I've just sort of taken us to panel 3. And another question, ways things connect, is Celeste framed things up in the beginning very much in terms of human biases, human cognitive biases. And of course, we have Danny Kahneman here, who's the leading expert in the world on human cognitive biases. Danny is wrinkling his brow, but here's the question for you. There's a vast, but to me, unsatisfying literature about how to ameliorate human cognitive biases. What can we do about them, given that we know that they're there? Either in terms of how we should, regulate our social media companies or critical thinking education or anything like that. So you've documented, and many people inspired by you have documented other biases. What do you think about interventions? Yeah, you muted.
Well, debiasing, I think it's fair to say, is not a success story. The efforts at changing the way that people think intuitively have not really been very successful. There is a big difference between cognitive biases and the kinds of biases that we've talked about here, the discrimination and attitude and motivation. I think there are really two families, and the interventions that are likely to work on both of those are going to be very difficult, but the difficulties are going to be different. We are two colleagues and I are just finished a book actually, in which we talk about not debiasing, but something that we call decision hygiene. And decision hygiene would be some prescriptive principles that you apply in thinking how to think or in thinking how to make decisions without knowing what are the biases that you're trying to eliminate. And in that sense, it is like hygiene, that when you wash your hands, you don't know what you're preventing. And there are principles of decision hygiene that, well, I can't say I'm very optimistic about that because I'm rarely optimistic about things, but it's a direction that one could go.
I really like that phrase. And while we have that room, Barbara, if we can tilt the camera, wanted to ask a question before that I think is even more relevance now that we have a broader platform about kind of different cultures and so forth. Do you want to frame that now? You're muted though. You're muted still, Barbara.
There are many things about the AI initiatives emulating people in some way or another that mystify me. One of them is that I tried to say is the reliance on words, when so much of human interaction and understanding comes in other ways, not in words. And another, I mean, babies certainly. Another is common sense reasoning. So, you know, you look at people I heard an interview with a woman the other day who you couldn't guess what political party she was in. And she said, I won't get COVID because I don't have the right vibrations. And you only get COVID if you have the right vibrations. Now, what do you do with that? It's a different kind of common sense reasoning. We have different periods of history with different explanations, religions, different ethnic groups describe and understand things differently. Different people come to. So I'm wondering what common sense reasoning would be. Would it look like? I mean, I have a similar question about innate and learned is, what would it look like? Now, some of you who've worked on common sense reasoning may have good ideas and thoughts on that. I'm a total novice.
Anyone want to take that?
I would like to respond, if that's okay, to the earlier point that Dr. Kahneman made about discrimination being fundamentally different or being in a different family than cognitive bias. I mean, and this is also related to the common sense point, but I mean, a cognitive bias is something that gives rise to discrimination. So one cognitive bias is outgroup homogeneity, right? So if I only hang out with white people my whole life, I confuse Black people. I think they're the same person. Right. And this is exactly the cognitive bias that then ends up with you thinking that like people who are Black are less good at something because you're not modeling those nuances in your bias. Right. I mean, I think this also goes to the point about common sense. You know, we can only build up our common sense based on our experiences in the world. And so it might be commonsensical to us to follow some sort of discriminatory path based on the biases we've picked up. So I just want to make that like very clear that discrimination and biases and how those are packed into model development are very closely tied.
Yeah, I just want to add to it, if I can. Can you hear me?
Yep, go ahead.
Yeah, I would like to add that some biases are launderable by AI systems. By virtue of us being able to point out the kind of biases that we are vulnerable to, we can design algorithms that repair those biases in certain areas, not in all of them. I'll give just a simple example. Selection bias in experiments, where the volunteers that are recruited for randomized experiments are taken from a different population than the population that you want to apply eventually the treatment to. That kind of bias, we just noticed that it can be repaired with, under certain circumstances, by modeling the kind of the biases that are being subject to. So I think it's an opportunity for AI to have algorithms that are bias plundered.
I could add to that.
Let's go on this. Oh, and then Robert, and then I'm going to change topics a moment after that. So Celeste.
Oh, so circling back to the point that Dr. Tversky raised, what do you do when somebody says that they think that they can't get COVID because they don't have the right vibrations? That's a question that we've been asking a lot in the lab, and we had been working on when somebody has confidence that's not justified given evidence in the world, how do you shake that confidence? And we haven't come up with any good solutions. Nothing we've tried has worked. What you do is maybe it may be too late. So one point that I want to raise is working backwards from that point and asking, how did that person get that idea? When you walk backwards, what you often find is that people went to the internet, they did their research, they maybe searched for a search term that they thought was kind of neutral, but that was going to bring uploaded results, and they came up with a stronger, a more strongly held belief than they would have had under other more naturalistic circumstances where you're walking around the world and it takes more time to collect the information and make up your mind, but that slowness allows you to encounter different sources of information, contradictory perspectives. This is a real problem with algorithmically suggested content that people have pointed out, but we haven't really dug in part because we can't, because the algorithms are proprietary. So asking how people got to these beliefs is a point that I wanted to make. I want to say one other thing, which is something else that's not obvious, but that we've been working on in my lab for a while, is that it's easy to think about there being a population of other people that are less careful than you that have misconceptions. When we survey people about a whole wide range of beliefs, what we find is that we all have beliefs that are not justified given evidence in the world. That's just inevitable given that we have limited time and attentional resources. So that's all of us. It's all of us that are subject to these biases that get left with the wrong idea. It's not just others.
Robert, and then I'm going to move to a different topic.
Right, so my point is quick, is that, so Dr. Pro just mentioned how you could model selection bias, and more generally, cognitive biases, some of them, not all of them, some of them are useful inductive biases for the very hard problem of induction. Point being is that these problems that we're talking about for the audience of machine learning researchers and practitioners out there, these problems that we're talking about, they're not just politics and philosophy, but they're actually very interesting technical problems that are very much worth diving into and chewing on. So I think it's a really important point to make.
I'm going to move on to a different topic because I'm watching the clock here. And it's a little bit selfish. I'm building robots, and I'm very curious what Fei has to say about it, and it connects to something that Danny said. So about System 1 and what's in it. So one of the things that I assume is in System 1 is physical reasoning. Not all physical reasoning. I mean, there's the physics that you might do in school, but the physical reasoning that my kids do when they decide that they can walk on a log, or that that's a worthwhile experiment to do, is really interesting, and it's something that's largely eluded robots. So most of the robots that we have right now do very limited amounts of physical reasoning. They know how to avoid objects with various kinds of sensors, but they can't really, in general, reason like just how to navigate an everyday room. Whereas I can look in everybody's background here, almost everybody's background, and make some guesses. Like, I think I see maybe a kitchen behind Doris, and I can make some guesses about how it might navigate through there based on a two-dimensional image that I haven't even gotten multiple viewpoints on. So Fei, I know you're starting to think about physical reasoning and embodiment and so forth. I'd like you to jump in. Yejin might have some things to say. Whoever else wants to jump in on how we're going to solve this question of the side of physical reasoning that maybe fits in system one, that's unconscious and automatic. For human beings, we do it very effectively. It also enters into language because we often reason about the physical world when we interpret language. Barbara might have something to say. So I'm opening that up broadly, but starting with Feifei.
Yeah, thanks, Gary, for asking this. You know, for my early part of my career, I spent most of my time believing that seeing is understanding, and it's a very passive way of looking at the world. And if you look at things like image classification, but it really, I had a switch of heart and dawned on me that embodiment and interaction is a fundamental part of intelligence evolution and development. Whether you have babies and observe the early years, or especially the pre-verbal year or months of the human life, and also most of animal evolution. So I cannot agree more that physical reasoning is part of the larger principles of developing intelligence. And I think I don't necessarily feel we have to go through the route of physical robot per se, especially with the advances of simulation environments. We see a lot of exciting work emerging from academia to industry labs on learning agents navigating and interacting in simulation environments. And I can dive even deeper into what we are doing.
I'll ask you a specific question there. I've seen some of the amazing simulation work from your lab recently. There's something missing, although you're probably working on it if I know you, which is affordances. So there's very good stuff about kind of navigating and what you'll see in different places, and reconstructions of rooms and houses. You can maybe post a link. We'll have a place later. Really amazing stuff. But when it comes to embodiment and how I think about like my kids, now they're 6 and 7, but when they were like 2 and 3 and learning about the physical world, a lot of it was about physical affordances. So I can hold this pencil, or I can hold this phone, or maybe I can take off the case. I did this once before, I can bend the case, and isn't that interesting? How close are we to being able to simulate any of that stuff, the kind of physical interactions with the world?
Oh, it's definitely happening. I mean, you're right, we're working on this, but there are some even bigger leaders. NVIDIA has this incredible physics models. There's a lot of physics engines happening, and interactivity with objects and environments. We've got work from Kristen Grumman's group looking at learning object affordances by interacting. So it's one thing I really believe in is, Gary, I talk about the dialing between explorative to exploitative experiences for embodied agent, and whether it's animals or humans or intelligent agent, we go through that in and out in such effortless way, and also sometimes task driven, sometimes it's goal driven. And I think we have to have that in the next chapter of AI development to solicit these learning principles.
Rich, it strikes me you might want to jump in here as well. You've probably thought about these kind of things a lot. You're muted though. How does that?
Strangely, I try very hard not to think about the particular contents of knowledge, and I like to, because I'm trying to capture the abstract principles. So I try to think of how we think about space as being similar to just the way we think about everything. So how do we think about things? Well, we imagine a state, we imagine something we might do, and then we imagine what might result. Then we put together these beliefs about transitions to a belief about what we should do, what we should value. So I kind of resist this question. I don't want to think about physical space as being a special case.
Barbara, do you want to say anything there?
Yeah, I'm
muted.
Yeah, I'm unmuted.
No, you're not.
I want, as usual, to open questions, and Feifei alluded to this briefly, and that's how much we learn from other people, from watching them, from doing and from interacting with them. So, and as to the physical world being having a different set of explanations than the living world, that may be built in, Gary, in your sense, that till infants understand trajectories of motion that are caused physically, like billiard balls bouncing against walls or sides, and self-motivated trajectories, which need to have something active creating them because they're doing things that wouldn't happen in the natural physical world. But I'm also thinking again of social interactions, of imitation. And imitation, again, in small children, isn't of the exact movements, it's often of the goals. So the exact movements are made differently because the infant is picking up the goal. So I just want to put those things out as challenges for anyone who might have thoughts on them.
I think goals are incredibly important. One of the papers you might be alluding to is in Science, Georgi Gergely, maybe 5 or 6 years ago, where there's an imitation that 14-month-old is doing, and I won't be able to reconstruct the experiment exactly right now, but kids will either imitate the exact action if they feel like that's the appropriate thing, or they'll realize that the person who was doing the experiment was doing something in some crazy way because they were encumbered. And instead of copying what that encumbered person is doing, they'll just do what that person was trying to do. Like the person's trying to touch something, they do it with their nose because their hands are tied. Well, the kids won't do it with their nose if their own hands are. Pretty amazing stuff pretty early in life. Of course, innateness is not equal to at birth, but it's clear that in the first couple of years of life that representations of space are pretty rich, representations of goal are pretty rich. And we don't really have good systems for that yet. Part of, I think, the challenge confronting us. And for Yejin, I guess part of the question is like, how do we represent that kind of common sense knowledge about other people's goals and the objects that they might want to know? But do you want to add anything there?
Oh, sure. And also, I would like to answer some of the earlier questions, starting perhaps from Barbara's question about language, because that was also discussed in the panel chat on the side. That often people ask me that, you know, my baby has common sense without language yet, and my dog has common sense without language yet. And it's true that octopus also has common sense without language. So the question is, do we want to limit that common sense AI research down to babies and animals, or do we want to make a system that can understand adult common sense as well, which, by the way, includes these social interactions, the implications of saying one thing at a time, and then you can reason about people's theory of mind. And in doing so, language is such a convenient representation medium for us, because if we try not to use language, we then have to define some symbol meaning something, and it just gets really messy and not very productive. So in relation to that, another frequently asked the question is whether we have to have embodiment. And I think we do, but it alone is not going to be achieving AGI in the following sense. Although robots and simulation environments are advancing a lot, I really don't think that we will anytime build a robot that can crunch into an apple to feel that juicy, crunchy feel that humans feel. So imagine that you build a simulation environment in which some engineers write a reward function that gives you some reward. How is that any better than compared to the language description of what humans feel when we bite into an apple? So to me, I mean, two things are both symbolic. It's sort of like not real experience, but they are both useful in some ways. But the simulation environment, the fundamental limitation, although I work on it too, is that we're sort of pushing the hard challenge of building the model of the world down to some software engineers building the simulation environment. I think there's going to be a fundamental limit. I think there were some articles written by a friend.
Ernie Davis?
Yeah. I believe he wrote an article about that. So there's that. But however, I think what Fei said about interaction, now this is really interesting, because even as a human, I don't think babies will really acquire language just by reading lots of raw text. We have to interact with the people. And I think there's a lot of developmental psychology study as well about how babies acquire words and concepts through interactions, through language, but through interactions. So even for language-only study, I do think that the missing interaction part is one of the major curious challenge that AI people need to think more of.
All right, another change of topic. I'm going to start maybe with Ken, and I bet Rich will have some things to say here, maybe other folks. The topic is curiosity. So you didn't, well, I guess you did use the word in the talk, and I've also heard you talk a bunch of times about novelty. And one of the things that really struck me watching my kids grow up, now they're 6 and 7, now that they're old, it hasn't really changed actually. Watching my kids grow up is how much they set their own goals. So I gave an example before of walking on a log in order to see if they could balance on it. So it seems to me that a huge part of what we have a gift for as humans, at least early in life until we become cynical and jaded, is setting ourselves an agenda that in some way advances our cognitive capabilities. This seems to be the genius of humans and perhaps some other animals as well.
This is not humans restricted, yeah.
It's not human restricted. I mean, humans are really good at it, but
many mammals, I mean, look at a young chimp, look at a young dog, look at the young cat, they're incredibly curious, and they have this drive to explore the world, right?
Totally agree. So Ken, are there any things out there that can help us to understand how we can build that into our systems? And other people can jump in, but I'll start with you.
Yeah, it's this is a big puzzle because, well, I mean, I think it's clear that curiosity is fundamental to early development and learning and becoming intelligent as a human is. It's not clear how to actually formalize or motivate curious behavior because it's not really clear how to formalize what's interesting. And so I don't always think of it in terms of like an objective, like, okay, now the kid has a new objective, jump on a log, and now the kid has an objective, like go play with that doorknob or something like that, as so much as the kid has some notion that certain things are interesting. And it's like a very perceptive notion somehow. And we all have this, but it's different in all of us too. We don't all agree on what's interesting. And so if we want to have curious systems at all the different range of human intelligence from like a baby up to an adult, like a mature expert in some field, we have to grapple with like this very subjective notion of what is interesting. And that means that we have to grapple with subjectivity, which we don't like as scientists. Benchmarks and stuff, we like being very objective about where we're trying to go. And so to deal with subjectivity, it means that at the ground below a lot of our assumptions, there's going to be something that can't be motivated objectively, something that is ultimately just something that we believe. And we have to somehow figure out how to get the AI to align with that. Because if we just say, go off and do things that are novel in some completely undefined way, a generic way, then it'll go deviate off into a space that we don't find interesting. So how do we align that notion with the things that we actually find interesting so that it can sort of plunder the space that we want to exist within?
I see Celeste raising her hand, and I think Rich was maybe also raising her hand. Go ahead, Celeste, first.
Yeah, so I'll jump in here. That there's cool work like from Pierre-Yves Oudier's lab at INRIA looking at this. We've done work with baby humans and also some non-human primates. You could have a high degree of variation in terms of the targets of people's curiosity without actually having any differences in terms of what people are applying. Because we know that people tend to want to, just like Dr. Kahneman pointed out, seek out stuff that's a little bit surprising given what they already know. Everybody walks a different road in life. Everybody encounters different stuff. What you would expect would happen if everybody was operating with a heuristic that's like, seek out stuff that's a little bit different from what I currently understand, is that natural variation that occurs in terms of what you're early exposed to and what you learn kind of builds. So you could have people having exactly the same rule, which is seek out stuff that's a little bit surprising given what I currently understand. And given that people will encounter different things and thus learn different things, you'd have different areas of interest across the population. So I think that could be applied to machines and has been applied with a lot of success to machines by people like Pierre-Yves.
Rich?
I have a different notion. An incomplete theory of curiosity. And this is based on the idea that people and some animals are striving to acquire a system that makes them feel in control. And in a system like that is identical to the one I mentioned that deserves the title Deep Understanding. A system that is able to cover all three levels of the hierarchy. And that has a certain template. So what drives people's curiosity is having holes in those systems. Wow, I'm sorry. The template is the same, but it may have holes here and there. So as long as if you have a certain holes in a certain granularity, you feel irritated or discomfort, and that drives your curiosity. When you feel those holes, you feel in control, and your curiosity is satisfied.
Rich,
That's my incomplete theory.
I'm going to connect with something else. Go ahead, Rich.
Very interesting, Yuda. So in reinforcement learning, curiosity exploration plays a number of different roles. I mean, I guess it plays many roles throughout theories of the mind generally. But in reinforcement learning, it has a really low-level role, like just to explore in order to drive the agent to try different things. You have to try different things to find out which one is better and how does. So you need something that forces variety. But in recent years, people have begun to look, and I've begun to look at a more larger role for I think what we're referring to now. I like to use the word play. We play means we set goals for ourselves that are not necessarily instrumental, but we're kind of learning, and maybe it'll be useful later. So yeah, we pick a log. Can I walk on this log? We pick some task, and we just say, hey, can I do that? Let's figure out what I'm able to do, what I'm capable, what affordances are here in the world. So for me, this is actually one of the four big things that I think people do, along with like perception, planning, and building models of the world. The fourth one is play. So what does play mean? Play means you've set yourself a task, and then you're learning the skill to achieve it. And then you'll have that skill available so you can maybe use it later to do various things to get reward. Play is a big thing.
I'm going to toss out a term that I see scrolling by here in the chat window for panelists from Francesca, which is metacognition. And I'll make it kind of a jump ball if anybody wants to talk about it, but I'll just say, I think there's some connection here that at least what I saw in my kids, it was kind of a metacognition. What can I do? What would I like to do? How can I make myself, have more skills? Does anybody want to talk about metacognition and how they think about it, how we might implement it? Do they think it's important here?
Yeah, let me start, Gary. So yeah, in trying to understand how to model this, thinking fast and slow in a machine, it seems to us that there must be some place, either within system one or within the system two capabilities, or somewhere else in between the two, where there is this introspection and metacognition. So where the machine, just like the human being, must be able to reason about its own capabilities, about how different it is, what the task that is presented compared to what it knows already, and to draw some conclusions and to say, okay, then I would like to more, respond in this way or in this other way, or I would like to define a new procedure to respond to this stimulus from outside. So to me, that is essential. And of course, it's not clear to me, how to implement it, but definitely I think it's either a module or it's a distributed capability that needs to be there and can be really helpful also in terms of curiosity and playing, as Rich was saying.
Anyone else on that? Or else I have an audience question. Go ahead, Louis.
Yes. From our perspective, of course, we want creativity, attention. We want to do that in a constructive way in AI. But eventually, what we want to do at the end of the day is to get the reasoning sound in terms of combining this perspective of parallel perception of the world in terms of system 1 and system 2, because they are integrated. I don't see them as separate entities. I think that the learning component of truly AI, truly sound AI systems, they have to see them in a convergent way, in a way that you conciliate what you're being learning within your experience in the environment. It could be like a reinforcement learning or deep learning. However, eventually the reasoning process has to be built in a sound way.
All right, I'm going to ask one, or possibly, if we have time, 2 more questions, and then we'll wrap up. And I want everybody to answer this next one if they're brave enough. And I'll do it in the order that we started. So I'll start with Fei-Fei, move to Louis, and so forth, so that we can get everybody in. I also thought about alphabetical, but so Fei-Fei, you go first. The question, and it came from the audience, and it's a good one, is where do you want AI to go? What would make you happy? You know, we talked a lot today about, you know, how to make AI better in different ways, but what is the objective here? The objective function for those of us who are building AI or trying to inform it from other fields. You know, what would count as success? Where do you want to take it to?
Okay, so as a scientist, I want to push the scientific knowledge and principles of AI further and further. And the first thing is start with some really fundamental laws and principles of AI. I keep saying that I still feel our AI era is pre-Newtonian physics, that we are still studying phenomenology and engineering, but there is going to be a moment or a set of moments where we're starting to understand the principles of intelligence. And that is the scientists in me wearing the hat of a citizen, I guess, and directing Stanford's Human Centered AI Institute. I want this to be a technology that can, in an idealistic way, really better human conditions, right? It's so profound. It's so horizontal. It's so, it has so much human and societal impact. It can be very, very bad and can be very, very good. So there, I would like to see a framework of this technology being developed and deployed in the most benevolent way.
Awesome. Louis, you want to take a stab?
Yeah, thank you. Thank you, Gary. Thank you all for organizing. This was wonderful. I like one of the sayings of Michael Rabin from Harvard and Hebrew University. He said that it's great that computer science has not been around for 2,000 years, and we are at a stage where very, very important results occur in front of our eyes. And I also like a saying by Alan Turing in his Mind paper, where he said, we can only see a short distance ahead, but we can see plenty there that needs to be done. And as Fei-Fei said, as scientists, I want AI to advance, but since AI is having an impact as big as physics had in the 20th century, engineering had in the 20th century, all the ethical issues, all the biases, and all the social implications that Margaret and others, and here and Francesca, have been studying, they are key as the responsibility of ourselves as scientists. And in terms of technically speaking, what we are trying to do is to conciliate traditions of AI so that we cannot see, and as you said, Gary, before, you've been saying since the late 90s, we have to converge, we have to look for convergency. You cited Yann LeCun, you cited other prominent scientists today. We need a way of seeing that several techniques can contribute to this endeavor of making AI fairer, AI less biased, and AI to make something very positive for us as humanity. We need, as scientists, to see our fields in a very humanistic way, so that not only the technical stuff advances, but we also have to be guided by serious and by effective ethical principles, laws, and norms, as Ryan said. It's hard to do that at the moment. We are at the beginning of an AI Cambrian explosion, as several people mentioned here, but we need to be very aware of the social, ethical, and global implications that AI has these days. We have to be concerned about the north-south divide, about the different cultures in order to regulate it properly. We cannot see it only from a single cultural perspective. So that's what I want to see AI researchers doing. They have to be concerned about the technical results, the outstanding results AI has been showing, but also we have to care about other people, about other peoples, other countries, and overall for the global health of the planet. Thank you very much, and Merry Christmas, Happy New Year to everyone. Thank you, Gary and Vincent, for the brilliant debate you brought today, and for the scientists.
That was a beautiful combination of your Secretary of State and your scientist. That was lovely. Rich?
Thank you. Artificial intelligence, it sounds like something very technical. But I agree with Luis that, or as he suggested, that it really is maybe the most humanistic of all endeavors. It's people trying to figure out how they themselves work, trying to make themselves better, trying to understand intelligence, trying to maybe make new intelligences. So I look forward to our greater understanding and a world populated with different kinds of intelligences and augmented people and new people and understanding and just novelty in varieties of intelligence.
Lovely. I think Judea is gone.
I'm here.
You're here. Okay, some reason I can't see you, but
I'm here, and my aspiration for AI are fairly modest. On the practical side, all I want is to have an intelligent and very friendly and super competent apprentice. I have only so many chores in my day, and if I had an intelligent apprentice, I'll be very happy. On the scientific side, I would like to understand myself, how I think, how I am being aroused emotionally, concerned emotionally. And there are some difficult scientific questions about myself, about our system of thinking that I don't have yet a solution for. And I know that emulating myself will be understanding myself. For instance, consciousness, and for instance, free will. If I can build a robot that has the kind of free will that I have, I'll take it as the greatest scientific achievement of the 21st century. And I make a prediction, we are going to have it.
All right. Next up is Robert.
Yeah, so much of the focus about the public debate about artificial intelligence is focused on it's automating a way of humans from things that humans do. And that's obviously a very important component and worth debate. I think in some of the previous speakers have mentioned, it's interesting to think about how this could actually augment human intelligence and how it could, for example, enhance meaningful human experiences. So with all the discussion about GPT-3, I've seen a couple of posts where people have written editorials or blog posts or even poetry using these large language models. And I'm thinking to myself, like, Bill, why would you want to do this? It's just remixing whatever elements of poetry or hacky blog posts you found in the corpus. And why not, wouldn't it be better to build something that actually helped poets create novel poetry? And so rather than, remixing is great. I mean, I like pop music, for example, but I mean, we'd also like to hear some novel, truly creative new endeavors. And so I'm hoping that what AI does is, when Photoshop came out, the first people to use Photoshop were the engineers who built it, and they'd make, those kind of matrixy, lawnmower man images of virtual reality people. But then nowadays, if you are a designer, no designer worth their salt doesn't know how to use Photoshop. I'm hoping that AI will do for meaningful human experience what Photoshop has done for design.
Awesome. Ken.
Yeah, so I mean, first, I think it's just interesting how difficult it is to articulate what we're trying to accomplish. It's such a great endeavor. But I think for me, it's a little bit along the lines of what Robert just said, where I think that we have to be doing this for ourselves. So we definitely don't want to get rid of ourselves. And so what does that mean? I guess it means that there are things that we have the capacity to do as individuals and together that that we need help to do, but we can't do without some help. And so in some way, like, for example, I know great art when I see it, but I can't produce great art. I know great music when I hear it. And somehow these kind of latent capabilities that we have maybe could be made more explicit if we had the right kind of assistance. And so in some way, I think that what AI can do and would be really exciting if it would do is just amplify us and our capabilities and give us the ability to express ourselves, which I think is like deeply what we just really want to do anyway.
Fantastic. Dejin?
Sure. So, yeah, I think personally, I have two things that I'm really excited about AI, the potential of a future AI. So partly, it's just really fun. We've been talking about curiosity earlier, and I think what's really fun right now is this curiosity about how to break things and challenge existing assumptions we have about the learning paradigms, so that finally we might have some real crack at human intelligence, and be able to create things that do wonderful things, amazing things that we could never create before. So there's that sort of intellectual gratification, and I would like to I would like to stay optimistic that we can go very far in the next few decades. And then I have this other part of me. So equity and diversity is really deep in my heart. And I'm really amazed by this opportunity that I have both in education as well as research to make the world better in that regard, improving biases that people have. And I think fundamentally human biases, they don't know if they have a biases, otherwise it's not unconscious biases. And we might really be able to help them to wake up by creating AI that can help them understand what sort of biases they have. But we have a lot more to go. So excited to see what happens next year.
Very good. Barbara?
So I see lots of AIs here. AIs that are trying to emulate people. And there I worry a little bit of, are you trying to emulate the mistakes we make, our biases, our misinterpretations, or are you trying to perfect us? So that's one set of AIs. I see other AIs that seem to be acting as tools for us, and then worrying about implicit bias in those tools, and worrying about how humans perform the same functions in a way to make humans even better at those functions. So the creativity, the music, the poetry, all of that is helpful. From my own point of view, what I study human behavior, and I'm always interested in what the AI community can create and what it's interested in, because those issues have always been eye-opening to me and make me think of different ways that I should study human behavior.
Awesome. Danny?
Well, I first became interested in the new AI, I think, through Demis Hassabis. And that was a few years ago. And I'm really struck, in a sense, by how much more modest you seem to be now than he was like 6 or 7 years ago, when he had a very simple slogan: solve intelligence and then solve everything else. And that's the motto, I think, of DeepMind to this day. That's a wonderful hope. It seems to be very distant. It seems to have become actually more distant, I think, in the last few years. Another observation that I have to make is, and that's about the idea of an apprentice. of, and actually this idea comes up all over the place, that humans should remain somehow in control. Here, I think there is real room for pessimism, because what we find is that once AI or any system of rules competes with human judgment, eventually they will beat human judgment. And the idea that they actually still need a human, I think probably not. So what we're going to see, that when there is a domain that AI masters, then I think humans will have very little to add in that domain, and that could have very, very complicated and I think probably painful consequences.
Next, we have Doris.
Yeah, so my goal is to understand the brain, and I think the brain is complicated, but it's not hopelessly complicated. And I want neuroscience and AI to work together to develop the simplest, most powerful, and beautiful explanation of how the brain works.
Fantastic. Adam?
Well, Gary, I think many reasons. So one, I think it's fundamental to basic science, not just neuroscience and the brain and how do babies work, like you were asking how your kids work, Gary, but also, how does evolution work? How does culture work? If we can crack this open-ended complexity generation thing that Ken Stanley was talking about, that will be fundamental for the natural sciences as well. Second, I hope it will amplify human creativity. So both the most advanced scientists will be able to do more than they could on their own, but also, some random kid could design a space station. Then I also think that it may lead to huge societal changes. Maybe it'll get us something like a universal basic income, really change society. Right. And then finally, maybe it'll be our descendants in the universe in thousands of years, going out into space. So there's a lot of reasons to work on AI.
Christoph. You're muted, Christoph.
As a scientist, I look forward to working with AI to help us understand the brain, because there is a continuous influx of AI and AI-powered machine learning to help us understand these fantastic data sets. But as a citizen, I guess, as Feifei emphasized, I also feel that much of AI is naive as concerned the medium or long-term future. And self-serving AI has accelerated. In fact, I think tech is part of the reason for the growing inequality, and I don't see that lessening anytime in the next years. The growing distrust in our societies, not only in the US, but worldwide, the tribalism, the strife, the social media. And then I was surprised today, Gary, quite frankly, when we talk about ethics, what comes to mind very often, so I hang out because of the family I'm born into, with people who work at State departments, who deal with international laws, military laws, etc. And there's a big concern here with militarization of AI, right? Danny just mentioned human decision-making, humans in the loop, right? People are trying to negotiate treaties limiting. Should we limit? Should there always be a human in the loop when we build dangerous machines, killer robots, as well as is happening, as we all know in the defense world, and as will happen. So what about the growing threats of militarization of AI, which is ongoing, and what should we do anything about it, or pessimistic, can we do anything about it, or is that just genie out of the box?
Glad you raised that. We hadn't touched on it yet. Celeste.
I don't think I have anything to add.
That's fine. I think we did good coverage. Margaret, if you like, and then Francesca and Ryan.
Yeah, thanks. So similar to Celeste, I suppose we're near the end. So want to sort of ditto, I guess, a lot of what other people have said. But so I'll sort of come at this from a cynical angle to say that my goal, and I think a lot of people's goals in developing AI, is that they find it interesting and fun. And I think as academics, we are very good at post hoc rationalization and justification of the work we do as being noble and great and having these large spans. But fundamentally, part of what we're doing is just sort of entertaining ourselves. And I think it's really important to be clear on that, because that's actually driving the decisions we make maybe informed also by these longer term goals, but there's this actually just a sort of this self-serving kind of pull that's really creating a lot of this. So I think that's just worth flagging. I think everyone knows that, but for the public generally, it isn't all just noble goals. It's like nerds nerding out, right? But the other thing that I really am hoping AI can be used for is to disrupt human biases. So for example, when you write a performance review, it's more common to talk about how women have communication difficulties and use language around communication difficulties. If we had AI capable of understanding the kinds of language used in different kinds of performance reviews, then it could actually interrupt and inject in a discriminatory or in an unequal process by noticing that unequal process. So I would love to see AI sort of turned on its head in order to handle really problematic human biases.
Francesca.
Yeah, I mean, I really have to follow up on what was just said, because I mean, okay, in the practical terms, one could say, oh yeah, okay, AI can help us amplify our capabilities, solve difficult problems, some of those that we created ourselves, but now we don't know how to solve. So maybe it can help us solve difficult problems in various domains. And it can help us, of course, understand ourselves, understand our intelligence. But I think that what was just said is very important because, for example, from my personal point of view, I never thought so much about my values. What are values that are important to me before working on AI ethics, before understanding what values we want to inject into these AI systems, what AI systems should be used for and what should not be used for, weapons, other possible applications, So to me, of course, this is a personal thing, but I don't think it's just a personal reflection on my own values. I think it's something that the whole society and everybody has the opportunity to do, because a lot of media is about those issues around AI. So it's a way to reflect on our own values, so improve the understanding of ourselves, but also our awareness of our own limitations, bias, as we just said, and be more aware and more clear about what are the values. And if we can do that through evaluation of AI and what we inject into AI, then of course, everything will come through, like new rules, new regulations, new everything where our societies are built and what is done within societies in all the different endeavors, because of our better understanding of what and clarity about our own values. So that would be, the ultimate goal in my view.
I'm going to let Celeste reclaim her time.
I am gonna I was inspired by Margaret and Francesca and what they said, and this isn't exactly the answer to the question in which I agree with what everybody said, but I think that what I want from AI, it's more like what I want from humans, which is a different understanding about what AI is and what it's capable of. I wanted to bring up the Stanford case of them deciding who gets the vaccines, and there were only being 7 frontline workers that were on the list. And when people got upset, reasonably, and questioned the decision-making process, they pointed to an algorithm and said, like, oh, the algorithm did that. People are behind algorithms. They may make decisions that have unintended consequences, but at the end of the day, what we really need, I think, is a shift from thinking of AI as something separate that you can point to and blame, that is people can think of as more objective in a sense, to holding people accountable for the AI they develop and the decisions that they make that go into it, even if there are unintended consequences.
Ryan?
Yeah, I want the costs and the benefits of AI to be evenly distributed across society, both in the United States and globally. And I want the public to trust that that's what's being done. And I think that's impossible without changes to law. Just impossible.
Thank you very much. So we're a little bit over time. I'm going to wrap up, and then Vince will say a few things, and I will try to keep my remarks brief given the late hour. The first thing I want to say is I had very high expectations knowing all of you. And I was thrilled to gather you here all in one day, and my expectations were exceeded. I learned a lot. I loved all of your talks, and I especially loved this last question, getting so many different perspectives about why we're even doing this in the first place and what we need to do. I am reminded of the old African proverb that I'm sure you all know, which is it takes a village to raise a child. Clearly, it will take a village, as we've seen today, to raise an AI that is ethical, robust, and trustworthy. And it was great to have some piece of that village here today. So I want to thank our amazing panelists. This has been every bit as fun as I imagined it would be. I look forward to seeing you all again in person before long. I hope we'll have many more discussions in the years to come. So thank you very much, panelists. Give yourself a round of applause if you can. And then I want to also thank Vince, who is not actually, oh, there he is, visible in the top corner. He's donated all of his time to set all of this up. He's done all of the logistics. He's helped me put together all of the panels, done all of the publicity. Didn't receive a nickel for any of this. He just did it as the kindness of his heart, as a gift to the community. And we owe Vince a big hand. Thank you for that, Vince. I want to thank the audience. We have a huge audience. I don't know how big it is, but I think it might be in the tens of thousands or something like that. I hope you learned something valuable, and that I hope will inspire a generation of students to confront many of the challenges that we've raised today, maybe get some new ideas into the mix. And now it's over to you, Vince, for a closing and a special announcement.
Thank you so much, Gary. Ladies and gentlemen, we just had a hugely impactful and great AI debate too. My most sincere thanks to our speakers, Ryan Callow, Yejin Chua, Daniel Kahneman, Celeste Kidd, Christophe Koch, Louis Lamb, Fifi Lee, Adam Marblestone, Margaret Mitchell, Robert Ness, Judea Pearl, Francisca Rossi, Ken Stanley, Rich Sutton, Doris Tsao, and Barbara Tversky. And a very special thanks to our moderator and co-organizer, Gary Marcus. The conversation will continue on social media with the hashtag AI Debate 2.
There's one more announcement, and here it is.
Yes. Now it's time for the unveiling of the next Montreal AI Debate, AI Debate 3. We'll do the unveiling live. So many things to control.
Same time next year, but in Montreal.
Yes. So we will do the unveiling right now live on the screen. So AI Debate 3, you have the address. We'll publish the event. It will be live now.
You mean we actually get to meet physically, face to face?
That is our fondest hope.
Wow, that's great.
That is our hope.
That would be great.
So that is our hope that AI Debate 3 will be held physically in Montreal with the greatest mind in the world. I thank everyone at home for joining us. And that concludes the AI Debate 2. Thank you so much, everyone.
Thank you all.
Thank you, everybody. Thank you, Gary.
Thank you.
Happy holidays, everybody.
Happy holidays.
Thank you.
Happy holidays.
Bye-bye.
Bye.
Thank you so much. I will just end the webinar.
One more second. I notice Celeste has the huge long chat log. You can actually save it. I just did that. People can do it individually, and we'll somehow circulate it among the panelists, because there were lots of ideas. I couldn't read them, in the corner of my eye very well. I just picked up on words like metacognition.
Those are not part of the official public record.
You're not.
No, those are offline. So what I will do is that I will just end the live stream, and I will let the webinar on Zoom between us to run.
Okay.
So
yeah.
Cool.
Yes. Cool.
That was his polite way of saying we're still being televised.
Yes.
Let's not have Ronald Reagan moments.
We will remain tasteful.
Is this still live?
Thank you. Thank you, Gary. Brilliant work from you. Brilliant work from Vince. All the